Hello guys, welcome back to Techdose, and in this video we are going to look at system design of real-time global payment security system using Agentic AI, where we will be using retrieval augmented generation to design our entire system to do real-time fraud detection. So in this case we will be looking at fraud detection in real time, real-time auditing as well, and then we will be discussing many trade-offs, and one of those important trade-off is going to be high recall versus lower customer friction. Then we will be looking at real-time processing, how we carry out real-time processing using Apache Flink. Then we will also be discussing the points of how to anonymize any personally identifiable information. That means implementing the GDPR or the data protection regulations. And we will see this everything designed with Agentic AI. And there we will be looking at Agentic RAG system, including the LLMs, vector DBs, and many more items. So please watch this video till the end to get a complete understanding. Let's get started. So before starting the class itself, the requirement currently is about system design with AI, system design with AI. And in the past, the requirement was just system design, and particularly for large scale design, you can expect a distributed design. But currently, uh, people have been asking about developing the AI features and where do the agents actually fit into the design. Okay. So agents can come in many shape and form. One of that form can be in the development work that you get right in the first round. If you appear for some companies, you can get 24 hours work, 48 hours work, something similar, where a problem statement is given with some requirement list. You have to figure out what you are going to do, figure out the entire workflow orchestration, and use Google and the entire internet to get the job done. That's how it is for the development job. Then in the DSA particularly, it has not come. So DSA round is the same as it was. Just the difficulty level is shifting. In the design round, uh, with the addition of new features, you can see around you that the applications in the past, how it used to be, and what are the new feature addition. You might also be getting forced in your own team to develop or add features regarding AI. You might also be getting KPIs regarding maybe 20% work or 50% work must be related to AI or some kind of AI workflow, right? So some deliberate force is also made. So that deliberate force is made in all the companies, and everyone is trying to incorporate more AI features, and that requires their design to shift as well. Like, how will you actually make it happen? Because the design components in the distributed design, which were not incorporating such things, may not be the same. So where do all those things fit in, right? Then there is a lot of buzz about the AI agents and where do they fit. So actually, the agent implementation is required only in the development work. For 24 to 48 hours work, which I'm telling you about the assignment, there you might need it. But even to think about, I mean, developing something is not a big deal if you are already a developer, because you might have done the search and you know how to search and do something new. The main part is to actually design a workflow and think about what to do actually. Because once you have got the idea, step by step idea of what to do, then you can do it because you know how to search and do. That's your skill, right? That's the skill of a software engineer. So the main problem is to think what to do exactly. If you are totally blank, then that is not going to help you in any way. Okay, so that is to cover that part of how the agents work and how we can expect the AI to work, and how to even think about it. Like, what is the expectation and what is a good expectation and what is a bad expectation. To learn about that, I am covering that in the AI for SDE. That is actually a 6 months course, and it is all about knowing about like how it is going to work. What is the good expectation and bad expectation? Okay. Definitely, the easiest part is for you to go through the documentation and use the API calls and just integrate. But how will you think about doing something? What should be the step-by-step flow? For understanding that, you should remember that trade-off is the main thing that any interviewer is looking for. Even if it is a DSA question, it is all about trade-off. It is about the best solution, worst solution. What is the solution? How do you do that trade-off? What is the trade-off? Maybe complexity versus something, right? In design as well, a lot of trade-offs are there.
latency versus this availability versus consistency, and a lot of things are there, right? Same thing is also present in AI. You may have to do a lot of trade-off discussions in your own mind, like why should I choose something and why should I choose something over the other, right? And how this thing will be combined with the system design becomes more and more important as soon as you climb up the ladder of the engineering. So it is the least important for SD1, but you can expect it to be the most important topic for senior engineer. Okay. And the focus on design was not as much 4 or 5 years back. You can just read a blog and you can just get through the rounds at SD2 level simply. But right now, the expectation is quite different and a lot more depth is required and with a lot more clarity and a lot more future scope too. So today's problem I have designed with the goal of giving you a step-by-step overflow of using an example of a global payments system. And I'll show you like the step by step what are the expectations, how much amount of time you are expected to invest, and how to define a future scope, how to define a good design, how to incorporate the AI agent, and where to incorporate it, so that you get an overall idea of how to club the system design with AI and how it looks like exactly, right? So that many of you have already done my design course and you must be knowing all about the distributed design and everything. But this is a new thing which I have never done in the past, not even till the current batch. So maybe planning to do it in the future. So how do you think about clubbing it together if you give your next interview? Because even if it is not asked, let's say the more senior level you go, the expectation becomes you should tell that this will be the improvement that you should be doing instead of the interviewer asking that what how will you incorporate that feature or this feature. You should be advising on what we will be doing and why we will be doing so, isn't it? So the more senior level you go, the more future scope you have to be ready with, and the more pros and cons you have to say yourself. So I'll take an example and I'll see like if you are a senior engineer, then what can be the expectation of answers and how to see a flow top down. Okay. And we will do that by taking an agent workflow also in into our consideration, right? So I think this has given you an overview. If you have any question, you can ask right now about the overview. Otherwise, we'll get started. And you can ask your question on design at any point of time. You need to raise your hand and wait for your chance so that you can ask the question, right? Why I have shared you the previous two videos. The past video, hallucination in AI and the rise of agentic RAG, is all about the RAG pipeline. So there I have explained in detail only about the agentic RAG. Today we will be using that. Okay, today we will be using that. Today is not about the pipeline of the agentic RAG. And the other one is a vector search on the vector DB. That is your hierarchical navigable small world of how at production scale, at a very large scale, top K recommendation is done in less than 1 millisecond. That means less than 1 ms. How do you do it at large scale? Okay, so that algorithm is HNSW explained in another video. Okay, so those two videos have been shared in your group. Please go through that later after the class as well, whenever you find time to connect all the dots that I will be saying, right? You, all of them have already taken 2 hours separately. So today's 2 hours cannot be clubbed together with that to make 6 hours class, right? So it would be helpful for you if you want to dive more into depth. Okay. If you are from the sixth batch and after that, I think you might have already done the vector DB, and based on that, you might have studied HNSW and the other stuff too. Okay. So I think I have set up the expectation. So let's define the problem statement, what we are trying to design today. And I will keep it at a level of senior engineer, let's say. And what is the expectation? Senior staff. If you are at a lower level SD2, anyway, in 1 2 years, you can be giving the senior engineer role, right? So it's always good to perform at a higher level rather than a lower level, isn't it? Even for SD2 interview, if you can do something better, that's best. Okay, so we are designing today. I'm writing the problem statement. You make out what we are designing. So in a senior engineer or staff engineer, you can just get one line or two line at max, just defining the bare minimum of the problem statement. So let me define that bare minimum. Design a real-time global payment security system that minimizes false declines without increasing fraud losses. Okay, this is your problem statement. Design a real-time global payment security system. So the point to note is it is a real-time design. Okay. Real-time global payment security system that minimizes false declines. Now you might be thinking, what is false decline? That means if the user actually wanted to do his own transaction, which was actually correct and valid, gets declined, saying that it seems suspicious, isn't it? That is a false decline. So we want to reduce that false decline without increasing the fraud losses. That means if somebody is trying to commit a fraud, then what do you expect? If somebody tries to commit a fraud, then the bank will lose amount, or maybe the user will lose amount. So generally, in most countries, the regulations say that the bank will lose amount, the user will not lose amount, right? Okay, that is the question, and I can name this as real-time global payment security system. Okay, just think about it for 2 minutes. Think about what will you design, and I'll come back in 2 minutes and start. Okay.
If you are someone who is preparing for top product based company interview, then we have brought for you live interview training program based on data structures and algorithms, system design and AI for SDE. This will make sure that you cover all the requirements for data structures and algorithms, be it online assessment or the face to face rounds. We will be doing live practice on coding as well as discuss the assignments. We also have a self paced number theory course which you can take for difficult online assessment and face to face interview preparation, like Google Media.net and Code Nation. And for system design, we will be discussing the distributed design along with components, HLD, LLD. LLD is a self-paced course here, and we will be discussing everything keeping the AI aspect of design in mind. That is how AI agents will come into our design and how to develop AI features in the pre-existing design. This will definitely give you an edge in the current AI era. And then we have AI for SDE 6 months live training program where you will be getting to build a LLM right from scratch. Along with that, we will understand the entire pipeline of Agentic AI. And this is not just a theoretical course. We will definitely be doing hands-on for each of the concept that we learn on Python using Jupyter Notebook or Google Colab. If you do not know Python, then definitely we will be learning it on the go. To know more about this training program, you can WhatsApp us on this given number or visit our website techdose.co.in.
So what should be step one if you get this question? Any recommendation? You want to get the requirement, isn't it? You want to first clear the requirement. As soon as you reach to this senior level, you should drive the interview. You have to ask all the requirements. You will not get any more requirement than what is already given. Okay. So uh, what will you ask in such kind of scenario? What would be your requirement and scope? Functional requirement, non-functional requirement, right? Two branches. What will be the functional requirement? What you are considering as the non-functional requirements. Writing both of them are quite simple. Particularly non-functional requirement almost remains the same across design. What is the availability, what is consistency, and all those things, right? All the trade-off point, latency, and other things. Let's think about the functional requirement because that will actually define where your interview goes, how your design will look like. So first of all, in the functional requirement, are you looking for high precision or high recall? High recall means what? High recall means the number of number of times you say that something is a fraud is not actually a fraud, right? Some number of times, like let's say you said X number of times, you predicted that something is a fraud, but it is not a fraud. Okay, Y times you have done it correctly. Okay, so these are the total predictions by how many times you have predicted correctly. If Y times you have predicted correctly and X plus Y is the total number of prediction in the category, then the recall will say about what is this ratio. I want to reach to 1. 1 recall means every time you do the prediction, it is correct prediction. Okay, so are you trying to increase your recall, which means that are you trying to be less and less inaccurate whenever you answer something that is more accurate? Okay, or are you looking for high precision, or let's say something like high uh, you can say customer experience. Now when you think about customer experience, then customer will want that as soon as they tap the card, as soon as they try to pay, immediately the payment is done. There is no there is no lag, and there is no decline. Unnecessary decline should not be there. Yes, the for fraud, definitely you don't want to proceed with the payment, but it should be like with the customer experience, whoever is willing to pay his own money should be able to pay with lowest possible latency without wait. And high recall is not considering latency too much. It is considering about making it more and more correct, right? So what is your goal? In our design, we will try to look at both the things as a trade-off, but my main important thing is how will we manage the recall while being decent enough in the latency. So I should have good latency. Let's say, let's say I want low latency for somewhere around more than 99% of the transactions. Less than 1% of the transaction is what I'm expecting. It will fall into some kind of gray zone where more scrutiny will be required, but I'm expecting low latency for definitely more than 99% of the transaction. Okay. So what do I mean by low latency? Uh, Now the number is not important if you are SD1 or 2, but the number becomes important that you give what is the definition of low latency. So I can say in in this case that less than 500 ms or less than 1 second, anything is fine. So let's keep it to less than 500 ms is the low latency. When I say for 1%, or I should say less than 1% of the transactions, I can do real time auditing. I have to do real time auditing because in real time I have to start reasoning about why I should decline or accept some kind of request for payment. So real time auditing is required for this. And what should be the expected time for this? Now you have to know immediately that if you are trying to do real time auditing with reasoning, because you have to attach some reason to why you have declined something, you must take a lot of time, and we will be using LLM in our design for that, and that may immediately make it around 10 to 15 seconds is what I'm looking at. Okay, still it is not very bad. Still it is not very bad. Now immediately you should think that what will the user see for 10 to 15 seconds. Google Pay have already been using this in the past. If you have used Google Pay in the past, you will be knowing that they use pending state for it, right? For something which is getting scrutinized more and more, they use pending state. Okay, so these can be functional requirement, simple functional requirement. We can add on to this functional requirement if we find something later, but the simplest thing is the latency. Latency can be actually in the in the non-functional requirement. Then this entire definition can actually be in the non-functional requirement. What I want is the recall. This is the functional requirement part. I want high accuracy, and I want good customer experience for 99% of the transaction, and that's how it is relating to low latency. Okay, and for 1% and less transactions, I definitely need to be more correct, and there I want high recall. That will actually balance the recall and the customer experience. Okay, definitely you can add what will be the availability of the design. High availability is something which I need. Okay, fault tolerance, high fault tolerance is what I'm looking for. All those things are in place, definitely. But these are the main things to compare. Okay, now think about scalability. I want a global scale design, global scale. So very highly scalable, global scale design. Think about throughput. Now, as soon as you define throughput, you have to attach some number to it, some kind of number. In this case, I'm assuming that 100,000 transactions per second is what I'm taking as the throughput. So my design must support this as a parallelly executable transaction. 100,000 transactions per second. Now, uh, later on when you go, even in the functional requirement, you should define about how much data should you take from the past to decide whether somebody is an outlier and committing a fraud. Because fraud, finding fraud is something like finding an outlier. Because something, if one, like less than 1% transactions are outlier, then those will be scrutinized more. So you have to find out if this transaction is an outlier transaction. And to define outlier, you should have a set of points. Now, how much set of points from the past are you going to take? Your account may be 10 years old, but maybe you were studying in India as a BTech student. Later for masters, you moved to US, and maybe there you are traveling because you are earning more, you are traveling more, and your nature has changed, like the how you used to live and how you used to spend. So should you include right from the past 10 years, or should you include only the past few years to be more accurate, right? Because more and more bad data you take, it is not going to help you out more. The data refining will help with the past or the recent past information rather than some old history, isn't it? So you have to be reasonable with that number. And let's say I will take that 3 years old data, I can take for some kind of prediction of an outlier, because generally it takes time to transition. It must be clubbed together with the recent past, immediately recent past, like in the last one day, what you have been doing. Have you been traveling from India to Japan, Japan to UK? Because traveling may affect your payment, in information. Suddenly you start hitting a DC in Japan or Tokyo, where you were hitting in New Delhi. Your data might not be replicated in the other regions. Okay. So these things should not be discussed right in the requirement, but you should keep it in your mind, because you, as soon as you see fraud, then you know it is outlier detection. You must maintain your own data points, and how you will do data refining, or what kind of data would be more relevant. That is what you need to think. Another very important thing to think in this case is the data protection law, the GDPR, the General Data Protection Regulations. It is called in EU. In India, it is called DPDP. Okay. So everyone has their own name, but we can say it is a data protection regulation. If you have data protection regulation, you cannot share the data outside of your country without masking the data. Okay, so something where the data is personally identifiable, it is called personally identifiable information. So personally identifiable information should not be shared with the outside of the country people, because they can misuse the information. So how will you manage that PIIs are controlled and masked values are sent? And how will your design actually handle this along with whatever we are designing? We cannot just share the data to any data center. Maybe you are a small country like the UAE or Oman, where you do not have a data center in your country, something like Bangladesh. They have to send each and every request to India, but they might not be willing to share their personal data information, personally identifiable information of their citizens with India. Then how will you make that design? Okay, so this question may not be applicable for SDE2, but this question should not even come. You should be the one who is asking that question. Okay, so are we following the GDPR regulations? Fine. Okay, so that is an additional part on top of it. So what we have found is we need real-time design, and we need some kind of real-time classifier in case of frauds, because a transaction can be just classified as something which should pass or which should fail, isn't it? So kind of a classification job. But in this case, I will classify it into three classes. Let's say something which passes, something which fails, because with confidence I can say some transactions passes, with confidence I can say some transaction fails. The gray zone is where I don't know whether it should pass or it should fail, and that actually should go to some kind of reasoning reasoner like an LLM to actually make more from the context of the past, right? So how do you actually find out in which category it falls to? How what kind of technique will you devise for it? Simplest technique to devise for classifier is using confidence score simply. How confident your ML is in seeing a transaction and what score it will give. Like how, like you will be saying this course has 5-star rating, 4-star rating, 3-star rating. So these star ratings are what? It is a confidence score that you back that okay, this course is at this level or meeting my expectation. You can say that greater than 80 is a pass, which means a very good confidence score. And you can say that less than 50 it is going to fail. That means you do not have enough reason to actually think about it even. It has actually hit some of your checklist point that it should fail. So I'm looking at something in between 50 to 80, and that is where I want more scrutiny to be done. Simple classifier, I mean, the score here do not matter. You can keep 60 to 80, 70 to 80 as the gray zone. It doesn't matter. But the main point is you have thought about it. You have thought about how you are going to classify. Okay. So, thinking about this till this point, you must be knowing that ML model is a separate thing than the LLM, because LLM will come when the auditing is required, when the reasoning is required. But this classification is done by a classifier, which is the ML model. So ML model must be separate, LLM reasoner must be separate, and there has to be somebody in the middle who is orchestrating all these things, right? That what the LLM should do, what this should do, or how or where should everything go, and what should happen. LLM cannot just take a transaction and make reason about it because it needs context on the information too. Where should it look? If you use ChatGPT, then you will find it is searching on the web, it is searching on the documents, scholars, papers, everywhere it will search, right? And then it will reason with your query, and then it will try to produce the result. So it should actually take information from somewhere. Now it cannot take it from the web because your if you are designing HDFC frauds, I mean HDFC pipeline, then you cannot take data from the internet. Data from the internet is not something you're looking. Data should be from your proprietary data. Okay. So so how to take that out? And you will find out that this entire design is the one that the financial institutes are actually moving towards and already adopting at a very large scale. And this is your agentic RAG, that is your agentic retrieval augmented generation. Whenever you generate your answers based on the retrieved information from your database, so that for each and every point in the answer you already have a reference point from the database. That is your retrieval augmented generation. Okay. And if an agent is actually taking care of all these things, it is called agentic RAG. So we will see it in some time. But let's just follow up with this requirement. So we have thought about how we are going to classify. So we need two levels. First level is a simple classifier. Second level is a reasoner for less than 1% of the transaction, right? I think this much we should agree that we will be doing this. Okay. Now let me give you some option of design after this, because depending on what path you choose or what the interviewer makes you choose, your design can vary. Okay, your trade-offs may vary too. So let me give you the first thing. Are you designing this for high frequency trading application? High frequency trading application, HFT. Okay, are you designing it for HFT, some kind of algorithmic trading company? They will just buy and sell within an MS. Simply, are you doing for them? If you are doing for them, then maybe high recall is something that they are not looking for, because if they take time reasoning, then their opportunity is lost and other HFTs are making profits. HFTs make profit by taking the action at the lowest latency. They do not make profit by just knowing the information, right? Otherwise, individual people would be making a lot of profit. When the individuals come to know about the stock market movement, the HFTs have already taken action. Okay. So it's about being fast. So here maybe I will do another change, that maybe low latency is what I'm looking for 100%. And then I will not go for LLM reasoner. Then I will try to try to think only in terms of the ML model. How will I make it the best model possible, and that will reduce my latency? So are we doing for HFT? In our case, we are not doing for HFT. But I'm giving you that if you are doing for HFT, then your focus should be only on the ML model, not on the auditing part. Yes, you can still do auditing, but that should be on the that should be a separate pipeline. That should not be in the pipeline of answering. Okay, the transaction should not be in that order. Second thing, are we doing it for a private banks? Private banks, and this private banks is only meant for millionaires and billionaires. That means people who are actually high net worth individual. You see that those kind of people are already separated in each of the banks by giving them a separate type of account. You see, in the banks you have separate type of account: zero balance account, you have salary account, you have millionaires account is different. Then the credit cards are also different type in nature: black credit card, platinum card, this card, that card, right? You might have seen a lot of cards. So each card may have their own separate algorithm for passing or failing the test. So for which type of card are we doing it? If we are doing it for somebody who don't have money only, they just do 10 rupees, 100 rupees transaction, then for them, I don't need to spend so much money in doing reasoning and all those things, right? For them, I will require less friction in making payment. Less friction in making payment means more purchase is going to happen. The companies are going to make profit. Nobody will appreciate you to increase the friction there. But if you think in terms of billionaires or multimillionaires, where a big volume transaction is taking place, 1 crore rupees, 2 crore rupees, $1 million, $2 million, in that case, even if you do one wrong mistake, it will become a big news and your company stocks will fall. Your company can be in problem. Okay, your company may not be reliable. So if you are designing for such kind of credit cards or such kind of people, I think latency is no more the matter. People will appreciate you to take 10 second, 15 second and try to be more and more accurate that this money should not go as fraud. Okay. So this is what we are looking to design. Okay. Because when I say high recall, I will be designing only for the high net worth individuals or people who hold money, at least the salary class individual, not below them. Okay. And I can also define certain rules that the volume that the transaction is happening is above 1 lakh rupees, above maybe a $10,000 or $5,000, then maybe all these things will come into play, even in the same type of accounts. Okay. So that is how you can make your argument and classification. So this is also in the requirement analysis, right? Okay. And then the third thing, GDPR rules have to be followed. General data protection regulation have to be followed. Okay. So, hmm, I think the latency requirement I have already put, that we need sub second or maybe sub half second, less than 500 ms per transaction. But only for some transactions where I will be doing auditing, real time will be 10 to 15 second. It should not fall into infinite loop, right? Yeah. So you know that if you are using some kind of retrieval augmented or even whatever you are using, AI stuff, you can find wrong answers sometimes. So how will you know where when you are finding wrong answers? So for that, most companies use link. Link means whenever you answer, you don't just answer. You provide a link from the DB. Whatever data I provided, you provide a reference to that. Like how the research paper is written. When the research paper is written and people try to make out some point, they always refer reference point 5, reference point 6. You can look at the end of the paper and you can refer back to those papers, right? So it is like that. If you use something like this, then the chance of getting something wrong is less because those papers were already approved, and approval cannot happen just by mistake. Okay, so since you have put the data, it is your responsibility that you put the correct data. Yes, you can do a data malentry and something malformation can happen and that can result into wrong answer, but that is not the responsibility of AI. That is the responsibility of the person, right? Okay, so I'm assuming that, okay, you will enter the good data. Based on that, I should not give wrong answer, but still wrong answers can happen. That is another goal. That is an unsaid goal that you have to achieve, that you should try to reduce hallucination. In the last class, we have already discussed that in a lot of detail in a 2 hours class about how this hallucination actually happens, even though you are using agentic RAG. And then how can agentic RAG reduce the hallucination and still lead to hallucination, and how to avoid that. Okay, so you can follow that lecture for more details, but let's continue with our design. Okay, now the interviewer will not say that you have to use agent and something like this, but you have to say, and then you have to also expect this question and you have to be prepared with your answer, right? So let's write some summary that whatever we have understood till now. The TPS, transaction per second, is 100K transactions per second is what we were looking for. Then the latency part, we were looking for greater than 99% of the transactions. I was looking less than 500 ms, and for less than 1% transaction, I was looking at 10 to 15 second where I require real-time auditing. Yeah, rules can be more complex. Above $5,000 only, above 2 lakh rupees only. All those rules you can add up to make this 1% and even less. Right. Okay. Now let's look at how do we achieve this GDPR compliance. Think about how do you do masking. Some of the companies you have worked in may be already using this. So can you have anyone of you used this? How to mask or some GDPR compliance or masking the actual entry of the user. Have you guys done that? If you have done that, then you might know.
Yes.
But yeah, so in that you have to use an anonymizer. The anonymizer is you can just think it like a black box anonymizer. It will make the it will mask the data. So user raw data can come in from one side. You can have a personally identifiable information vault which will map the anonymized data to the actual data. Okay, and the anonymizer can be connected to it. Whenever it is masked, you can store it as a kv pair. What is the anonymized value versus what is the actual value for it, which user I'm talking about. When I say user U123, then is he going to be Nitish? So how will I know? I have to use it I have to save it in a KV pair or something, right? So some similar structure you have to combine with the anonymizer section. Okay, fine. So this you have to take care. Now I have a question for you. Like let's say that some of these or most of these high net worth individuals will be traveling. If you have more money, then it is more likely that you are going to travel. Generally, for transaction, your transaction will go to the local data center or at least maximum your own region. It is not going to go to some different region. So if your transaction is happening at a place where you are in currently or from where you want to do international transaction as well, it will go to your own DC. But if you are changing location, 12 hours back you were in, let's say, Dubai. Next to in the next 10 to 12 hours you are in Tokyo. A Tokyo data center may not be aware about the things that have happened in Dubai right away. How will you take care of such moving transactions where it may right away reject the transaction in Tokyo? Let's say a coffee shop in Tokyo, you are trying to swipe your card and buy coffee. And since you have joined this bank because of the good user experience that you want, you have a lot of money, you want good experience, but then it says it is a fraud transaction possibly, and it will not allow. Then what will you do? You are not running away with the currency, physical currency everywhere, right? So isn't it a bad experience for the user? And that will also not lead to good reputation for the company. How will you take care of that thing? Any idea?
Replication.
Yeah. So you will definitely do replication. But very limited number of people will actually do such kind of international travels all the time. Even though you have a lot of money, do not mean that you will do this. So will the replication, if you do replication, you will have a high load. Let's say there are 100,000 users who have this type of account. Now for 100,000 users, if you are doing global replication, that will put everything under a lot of load. And with replication, I think you mean some active type replication where replication is done faster rather than just being passive, and passively it is replicating. After some time, it will get replicated, right? So you have to be a little more active, proactive. You have to provide a bound to the replication too, some kind of bounded replication, or so you can say bounded consistency is what you want. Okay. So if you want bounded consistency for so much user, it can actually land you into another trouble. Replication can solve this problem, but you can be in a trouble that large amount of data getting replicated will consume large network bandwidth, and it will impose lot of cost too. More data moving across the data centers will impose cost. So, is there any workaround for it that you can think? Replication you will do, but can you do some smart replication or something like, can you do something for those who are traveling only? From the past record, you know who are all those guys traveling, right? So you can replicate only those guys.
Yeah.
There will be, let's say, less than 2% or less than 5% who are actually traveling. Only for those guys you can do the replication. Your load immediately becomes 20x smaller, 20x smaller, 50x smaller, right? So much less. Now, if you are reducing your load, think about what kind of DB are you going to use for this replication? Because when you replicate, okay, you can replicate with any DB. I'm not saying you cannot replicate with other DBs, but think about what kind of design overall do you want in your global payment system? Is it going to be a leader master, I mean, the leader slave architecture, leader follower architecture? Is it going to be multi-master architecture? What kind of architecture, or maybe some kind of hybrid leaderless architecture? What architecture are you going to choose here? What makes more sense? Choose between two options: leader follower versus multi-master.
Leader follower.
Okay, so let's discuss about the leader follower. So if you have leader follower architecture, you have exactly one node who is the leader, and rest all the nodes are follower nodes. Think about Udyan being in New York City. He is trying to do a transaction where the leader is in Tokyo. He will have to move the transaction to Tokyo and then get an RTT. The RTT can be very high. And also there is a very highly likely that you can find congestion in the middle. You can have packet drops. Again, retransmission may happen 2 or 3 times. So it is the same like you are playing a video on your internet connection versus on VPN. If you play on VPN, what do you expect? You expect slower speed because it is connecting to some server far away. That server is connecting to on your behalf to some account, streaming to that router, and then sending you back. Definitely will be slower. So if the leader follower architecture is used, then don't you think my latency is going to be higher? And also it introduces another problem of single point of failure. Okay. Now you think how the transaction should happen. Each and every region's transaction is not related to other region's transaction. Why should it be related? It will only be related if you are moving across borders. For those people, definitely you will be replicating. For others as well, you will be replicating. But the nature of replication will be two different type of replication. The nature of replication for somebody like me who is always sitting in the same chair every day at the same place, it is still going to replicate, let's say, in New York City data center. But the goal of that replication is to maintain durability. It is not for any other purpose. It is not for low latency. Whereas the people who are moving across borders, the reason for their replication is low latency and not just durability. So replication may have different goals even though you are doing replication, isn't it? Why I said you have to actively replicate with a bounded consistency, because if you do it actively, then only you can maintain the data availability in a certain region, so you don't have to move across region. There will be no more confusion. There will be no fraud detection at some location. So you will get higher recall, you will get low latency as well, and a good customer experience overall. So you see how replication goal is changing depending on the user type. So replication do not mean that it is the old standard something for durability, something for fault tolerance. Yes, that is there. That is there. But the active replication is also including the other things that I said. So there can be like two types of replication again, depending on how fast you want to replicate, active replication or passive replication. Also your active or active passive type replication. Okay. So depending on how you replicate, again, this has been explained in detail in a video called Global State Replication that I have uploaded 2 weeks back, I think. You can go ahead and watch that too. Active, and active passive replication. Okay, so that is a different replication. Another type of replication is synchronous and asynchronous replication. Depending on whether you want it immediately with a strong consistency, you will go for synchronous replication. Otherwise, you go for asynchronous replication, right? So depending on your goal, the replication type will change and you can achieve any type of goal. Okay, so I think now you might have understood that maybe this is not a very smart choice for us. This is not a very smart choice, right? Let's go for the other option, that is the multi-master architecture. In the multi-master architecture, every node in every region can allow the writes to happen and everyone can sync with each other. Okay. So now if Udyan in New York City wants to do a transaction, he will send to some DC near New York City. So this will reduce latency, complexity, doesn't take the internet backbone, just works on the local network itself. All those profits are there. All the profits are there. So you can spend more time in processing if you want to process something. Definitely replication will happen, but that goal is for durability. That if something happens to this DC, maybe somebody throws a bomb on this DC, then still the other DC still has your data. So you can still replicate back. Okay, if this DC becomes unavailable due to let's say power outage, then your request may be routed to some other DC where it can have the data. If you do not replicate, then how will you see availability? So durability plus high availability can also be guaranteed. Okay, so a lot of things are there with replication. I think you already know a lot of things. In replication, we have already discussed a lot of things. Fine. So this is about uh, what kind of replication are you going to do? Depending on this, depending on the multi-master architecture, since all of the people like Rakesh will be writing in the New Delhi DC, then maybe Nitish will be, since he's living in, let's say, uh, somewhere in UK, he will be writing in some UK data center. All of them will sync together. All of them will sync together. Okay. Now you think about when you have some experience, maybe people might ask you about what DB are you then going to use, isn't it? What kind of DB will you use which supports multi-master writes? One of that can be a DynamoDB,
DynamoDB.
Dynamo, right? DynamoDB. Cassandra is also similar. Cassandra is also similar. You can go with anyone. If you are on AWS, you will be using DynamoDB. If you are on Azure, maybe you will use Cosmos DB or something. Right. So it depends on which platform you are on, but I think you can answer one of them and then you should be good. Okay. So multi-master, the main thing is it should be a multi-master architecture or a leaderless type architecture. Okay. So your answer should not be some DB with high consistency and then you are trying to maintain high availability and multi-master architecture. So strong consistency is not good on these things. It is tunable, but it is not the prime requirement.
Hmm.
Okay. Okay. So we have done this. Let's say uh, let's say we have made this happen. We will see further detail into this, what we should do while replicating in some time while we draw the HLD. But I'm just trying to make a case for the HLD, right? So what we have seen, user request involves performing a transaction. There can be two cases when user request comes in. Either the data center is in your own country or outside of the country. If the data center is outside of the country, before the data reaches to the data center, you need anonymizer. If the data center is within the country, your anonymizer can be in the DC itself. But you should not let it get out out of the country. That's my goal. So I will assume that the data center is not in my country, so that it is the worst case scenario. If it is in the country, then maybe you can add the anonymizer just before the processor. Okay. So I will assume it is not in the country. Then anonymization has to be done first. Now think about which unit should catch all the events. There should be some kind of unit in the middle which catches all the user request, and it actually assigns the job to particular worker nodes, worker 1, worker 2, worker 3. Who will do that? Who will be that unit who catches all the user requests, takes it together, and then transmits it to the workers? What do you think?
Load balancer.
Okay, load balancer can be one such unit. But let's say at a large scale, load balancer can be one such unit. But let's say I'm thinking about cluster of worker nodes, cluster 1, cluster 2, cluster 3.
Uh,
Depending on what type of transactions you are doing, type 1 transaction, type 2 transaction, type 3 transaction, you have more complexity to it. Platinum card transaction, then some different type of transaction. Who will catch all these things and partition it separately and will send it to those kind of workers?
Kafka
And
broker.
Kafka will do it, right? So Kafka will do it. We need a publisher subscriber model for it. The publisher subscriber model, what it will do is, on one side it will capture all the request, and on the other side it has multiple topics, topic 1, topic 2, topic 3, and so on. And each of the topics will have multiple partitions. Each of the partition is connected with one of the worker nodes in the cluster. When you send a request to the partition, it will go exactly to the same worker node. Okay, so Kafka would make sense in this case. Okay, so Kafka is something that we are going to use after the anonymizer, let's say, because anonymizer should actually mask everything, and after that Kafka should come in. Kafka will take and play the information to the worker nodes. The worker nodes can be assumed that these are in the DC. Now you think about this worker node and think about the problem that we are solving. We are solving a real-time global payment security system. So processing has to be real-time. Which unit or component is used in real-time processing?
Link.
Flink. We can go for Flink, Apache Flink. Okay. So Flink is used for your real-time processing. Now Flink will aggregate everything, process, and give an output. Think about where will the output go. So what I'm trying to do, a user is present or many users are present, giving the data to some kind of anonymizer. Okay, anonymizer is connected to PII vault, converting your personally identifiable information to anonymized values. This is going to the Kafka unit. Okay, let's say Kafka unit. The Kafka unit is sending it to some kind of stream processor, which is a Flink unit. Okay, it is going to the Flink unit. The Flink is a directed acyclic graph, right? So they are connected through, I mean, you can think it like a neural network, one layer connected to the other layer, something like that. It will produce an output. Where will this output go? This output, what should we do with such output? Flink will do stream processing, will aggregate transactions. Whatever you want to process, you can do it in the Flink. But what should it do after this? It should be going to an ML model, right? An ML model can be in the Flink unit itself, and you can have an ML model classifier, which will be giving a confidence score and classifying. Based on the classification, you can provide a check of whether something looks suspicious or it doesn't look suspicious. If it is good to pass, it passes. It will go to some kind of notification service, isn't it? Notification unit. And that notification service should actually give output to whoever has subscribed to this. Maybe the user, it's a user himself, and some other services as well, like logging, if you want to log it. Okay, so this is what we have actually come to an understanding. And this would have been your usual flow without including the real-time uh, checks, real-time auditing. Now think about, when will you do real-time auditing? After the score has been has been given, after the ML model has given the score, depending on whether the score is greater than 80% or less than 50%, you will either pass or fail. So it's not just about pass, you can also fail. But if the score is in between 50 to 80, you will have a separate flow. Okay. You will have a separate flow. So have you understood till this point, like what we are trying to do? You will have a separate flow. So when I write this 99% of the transactions or more transactions are less than 500 ms, I can easily write it at P99. That is 99th percentile transaction is 500 ms and less than that. Maximum 500 ms. Okay. Fine. So can we make it properly? Like let's make a proper diagram two side by side, and then we will again come back and try to see what should we do with the gray zone transactions. Yes, Rakesh.
So, Surya, will it this flow check only sender request, also receiver? What if receiver is fraud? Whether
So this is a receiver.
I
So if
mean,
the sender is
you
a no, 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 it will not. Okay. You are saying is if the receiver is fraud as well.
yeah,
In a transaction itself includes the sender and receiver. It doesn't mean that it is just the sender.
okay,
I'm
okay,
just assuming that you are considering both party.
okay,
But that
okay,
is the ML model's job to think that whether the receiving party has been marked as fraud or whether the spender is not you, like the authentication fails. The sender is not you, or even if authentication has passed, it looks suspicious or outlier. The outlier doesn't mean that the user is only the outlier. The outlier can also mean that you are suddenly purchasing from an unknown website which is not appearing in Google search from some remote location in Canada from India.
okay.
So that can also be an outlier. So the transaction, when you say, it has many attributes to it. It is not just the user. The all the attribute key combined together as a composite key will form just a single behavior. And that behavior we are trying to see whether that behavior is outlier, right? So it will incorporate everything. It will also incorporate maybe the amount. As I said, it is customizable, how much amount you are spending, on what item you are spending. Have you ever spent on such platform or such items, where you are spending, location, the latitude, longitude. All these things will form one behavior, one action. Okay, so everything will be included. So let's say we have an event collection or API gateway. Now I am assuming that uh, this API gateway comes before, but actually my design was about the data center being outside. So API gateway, or let's say the gateway will be for a country's gateway. That's what I'm going to assume. So whenever the user request goes in, it can go into some kind of local server. So I can just make it as an event collection, event collector. Okay, there can be many event collector across the globe. I mean, in the same country, there can be many event collectors locally. Event collector will collect and then send it to anonymizer, or there may be anonymizer unit. There may be anonymizer unit right in the event collector itself. But after the collection of event only, you can anonymize, and this will be connected to your personally identifiable information KV pair vault, which can interconvert from masked value to you can say the actual value, and vice versa. You can do that. Yes.
Uh, this anonymizer you have added this component after event collector. Can't we anonymize uh, like at the user's device level? I mean,
Users device level
from
anonymizing. Yes, you can do that. That is an application
because
logic to it. You can do
yeah, I
that.
mean, so here. Mhm. So
Mm.
here it is. It seems like somewhere events are getting collected in our system and then they are getting anonymized.
Mm.
So instead
You
of
can
that, I'm
anonymize in the application. You can send both the data, who is the actual user, who is the anonymized user. You can trim out the actual data value when you actually pass it through. So you will still have the PII vault, but you will send the anonymized value, comma, actual value, that will be stored in the log, and actual value will be trimmed out and the anonymized value will be sent forward. That can also be done.
Can't we
Or
only
you
send
can,
the anonymized value only, not the
I mean,
actual
if you
value?
just send the anonymized value, then the log will only log the anonymized value. Then maybe
Hmm.
again you need another conversion. When you are reading the log, you cannot just read it trivially. Then it will require
Decryption.
another set of operations. You should have PII vault every time you need the reading on
Okay.
the log, isn't it? So that is again a headache. And anyway, your anonymizer means that you are following the country's rule. So maybe if unless we go outside of that country, then until then it should be fine, right? Yes, Udyan.
Okay. Yeah,
Yeah,
that's
Surya,
what.
so I am having a doubt. Is it like similar to encryption and decryption process, like when we are sending data and we encrypt the data and then we decrypt at the, so is it like same thing anonymous
So it is
is trying?
like encrypting but not decrypting. The
Mm-hmm.
thing is, you are encrypting and performing the entire action, but
Mm-hmm.
no one will be decrypting it. The decryption will also happen at the anonymizer itself. Some notification service has to send notification. It will not know where to send it. It will send to the anonymizer, and once the notification comes inside the country, the anonymizer will see which user 1, 2, 3 you are sending. It will look at the PII vault and convert it to the actual user, and then it will send to the user.
Okay.
Okay, so it must go through again the anonymizer or some logic. Okay, so that's why keeping it separate makes it a more modular kind of a design, separation of responsibility. Otherwise, your device will have more job to do. That will decrease your battery life as well, isn't it? Consuming more battery. So when for app developer, I think you would want that your application should consume least amount of battery. Right. So battery consumption will be higher if you perform more action. So maybe that can be one of the motivation to do it separately, isn't it? Other things can be there, but yes, more control can be gained if you are doing it in this way. Less control, you have to push the update every time. You have to think about pushing all the devices, and some management hassle can be present. Okay. So separating responsibility, I think it's a better design. So let's keep it to that. Then you have the API gateway of the country. It is now going out of the country, and then you can give it to Kafka unit. Let's say the Kafka unit is consuming this, getting all the requests from multiple countries, and then the Kafka is actually playing it to the stream processor. So let's keep our stream processor at this point. Stream processor can be a Flink unit. As I said, it is a directed acyclic graph. Directed acyclic graph giving one aggregate output. Uh, at this output, we have seen it in the past that it has a feedback loop mechanism in the Flink. If you read it in detail, you will get it. So feedback loop, what is the meaning of this? This Kafka will be sending your output to this Flink. It will do aggregation. It can do it in multiple steps by feedback loop, learning the things. This is very good for machine learning when you have feedback loop, because you can keep learning again and again. And this is also very good for graph analysis and graph algorithms. Something like Floyd-Warshall, where you need to do step-by-step updates. Dijkstra algorithm need step-by-step update. Those step-by-step things can be done in a feedback loop. Very, very important. Okay, graph algorithms uh, and you can say machine learning models. Flink is pretty good at that, and it is also very good at real-time processing, and you can say kind of it can also do batch processing with the micro batches. So not it is going into the detail of this Flink, but we can say that it is a stream processor. After this, an ML model can come here into the same unit of the Flink. Let's say an ML model is what we have taken. This output should go to the ML model. I could have made it outside, but let's keep it in the Flink itself. You can also make a box outside. ML model will actually say about what is the confidence score. So your confidence score is going, and it will be hitting a check. The check can be a suspicious check. Suspicious check. On this suspicious scale, what value are you getting? So if you get any value below 50, you will fail.
If you get any value above 80, you are going to pass. Depending on whether you directly pass or fail, you can just send it to the notification service, notification service, and you can just send this information to the country's anonymizer, actually to the server, who will again convert it back and notify the user. And you can, many people can actually subscribe to the notification. You can send it to the logs to maintain the logs and everything you can do from here. Okay, so this is the usual flow that we have seen, and this is this flow will take less than 500 ms. 99% and more transaction, more than 99% transaction will go in this flow, because your ML model is already quite good, right? Now, only when the confidence score falls in between 50 and 80, then there has to be some separate flow. And what should be that flow? What should be that flow? Before doing that, where are we actually storing all the transactions? We have not made any kind of database. The database that we have made is for the PII, personally identifiable information. We have never made any DB. What DB should we use and where should we use? After which unit do you think the DB will come into play? Let's make a DB here, which will be the transaction record. What type of DB do you think should be taken in transaction record? And from which box can I connect? The output of which box will go into the transaction record? What do you think? Try to guess. Even if you are not correct, you should try to guess. Yes, Rashri. Rashri, you are not turning on your video. Okay, so
we go with Redis.
okay. So think about why Redis is used. Redis is assumed to be acting like a cache layer. Even though you can store information there, it is not very highly scalable, and you cannot store infinite amount of information there. It is more likely assumed to be present in memory, that is RAM. Even though you can say that it can also include the hard disk. But when we think about Redis, we think about a fast cache, KV type cache, which can maintain some level of durability and which can maintain cluster, and it can replicate across the world with a decent replication, latency. So here transaction record means that I will be I will be writing about all the transaction, and I will keep on writing. So it will be huge, isn't it? It is going to be huge. And also think like transaction record has to be present everywhere in all the DCs across all the regions. So it cannot be having a leader follower architecture. That is
DynamoDB.
number one. Yeah, so we'll come to that. So we cannot have leader follower architecture. You need to have master architecture. Okay. Every region should write independently. Redis is not at a scale of what we are thinking. Redis is more, we think to replace a cache. We need a cache, we use Redis. When we have to take a dedicated DB, then we avoid Redis, isn't it? Okay, so you can keep it like a thumb rule for that. So I think something like a master, as we said, Dynamo or Cassandra can be used. You can go with the Dynamo. Okay, the KV pair. Okay, so highly available KV pair is a DynamoDB. You can go with Dynamo. Let's keep Dynamo. You don't have to name it, but at least you should know that what we are trying to go with and why we are trying to go with this. It is a multi-master architecture and can write a lot, and it is very highly available too. Okay, and which output will come here? Output from Kafka will come, output from suspicious activity will come, notification service will come. Ah, which output should come?
From
It,
Kafka, it can
it
go.
can come from anywhere, but I think if we just write from Kafka, we have not yet made the decision. So how will you feel that attribute of whether this transaction has passed or have not passed? Then you may have to also connect. If you connect from Kafka, you may have to also connect from notification too. Or at least you may have to connect from this unit, whether it has passed, failed, or it is in the gray zone. What has happened, isn't it? So then
it becomes redundant, because after connecting from the output of ML model, you could have just written it rather than taking from Kafka, because anyway, taking from Kafka is not giving you the result. So I think you should take it from here and write it. Even though you could have written from notification service too, but let's say that I will right away write, because something happens in the middle, at least I'll maintain something, right? Okay, fine. So I have written to the transaction record now. It can pass, fail, or it can be in a gray zone. Now you think, how will you define gray zone? How GPay defines gray zone? That is, when you try to do system design of GPay or any kind of UPI, how will you define something suspicious in the middle and under processing? You say processing only, right? Processing or pending. That flag has to be present. So there will be three flags. There will be pass flag, fail flag, processing flag, processing or pending. This flag has to be set here. Now this flag has to have a maximum bound time between which it should either pass or fail. It cannot keep on hanging for 5 minutes, 10 minutes, isn't it? The main problem of GPay in the past was it was in the processing mode for a long period. Now it has removed that problem. Now even if it is in processing mode, in just few seconds, it will change to either pass or fail. 5 to 10 seconds it is taking to change. I think few seconds, 10 seconds around that it is taking to change. That's exactly the functionality that we are looking for here. Okay, that's the same functionality we are looking for here. So we want pass, fail, or processing mode. Okay, three flags. So in the transaction record, you can see that one of the attribute in the row is going to be what is the status. When you do the data modeling, in this class, we are not going to do data modeling, but I think you can do it yourself, that when you design the data or the schema, you will have status as one of the flag. User ID, who is sending it, maybe the UID who is sending it, maybe the location from where he is sending, maybe any other information that you want. What is the amount of money he is sending, to whom he is sending? Okay, then you can have something like the time he is sending, the timestamp he is sending at. What is the status of his processing? Is it allowed or not allowed? Okay, and you can add many more things, whatever you feel like. But I think these are the bare minimum that you can add. Okay, now we have put a DB in place where all the records will go. And definitely, I don't need to tell you that this will be replicated. It will be durable, fault tolerant, everything. That is a separate design, DynamoDB. Okay. After this, the suspicious activity should also emit another output, which should be like gray zone output, 50 to 80 output. And this should go somewhere. It is the suspicious activity. Suspicious, right? So somebody has to do further scrutiny on this. Who will be that somebody? Let's see. That somebody will be another person. Like, think about it. When you need to get your, or maybe in the past, if you need your Aadhaar card, or if you need your PAN card, or if you need your passport, what would you do? You will find somebody whom you will pay money and he will do everything. He will drive the car for you, he will get the driving license, he will give it to you, right? That's how it is. Or maybe he will pay money to some connection and he will get the driving license for you. You will get the license. That's how it works, right? So in many of the cases where you do not want to put effort, but you want to get the job done, you ask somebody to do that job. You don't want to give interview, you ask somebody to give your interview, right? You don't want to come to the class, you ask somebody to give your attendance in the class. You ask your junior to go to the class and sit, isn't it? Even though the face is not matching. So who are these guys? These are the agents. We call them agents, right? We have been using agents from a long time. It's not like with the advent of AI, the agent has come. Agent was always there from thousands of years. Okay, so agent is what I'm going to use. So a service we have to design where the agent will be in place. Now keep in mind that there can be one or more agents as well. Generally, in most of the agent service, you have more than one agents. Okay, so I will be writing agent service. So let's write agent service here. Agent service here. After the HLD, we will have a lot of Q&A that I have prepared, and you will be answering those Q&A, right? Okay. So let's say that this suspicious activity has emitted the gray zone output 50 to 80 score and sending it to the agent service, right? Suspicious. Suspicious looks suspicious. Score is 50 to 80. It will be going to the agent service. Now, agent service is not a magician. What do you think the how agent is different from you? If you know some agent who can get the passport done, how he is different from you? He is different in the sense that you do not have connection and he has relevant connection. He can pull the strings. He knows who's to whom to pay how much money, how to get the job done. He knows it, right? And he can also scrutinize on the things where whether the job is done or not done. Even though the other party may claim that the job is done, the agent can still verify if the job is done. And if the job is not done, whereas the others are saying the job is done, he can resend the job and say that this is not done and this is the reason it is not done and you please do it again. There can be multi-layer step. Maybe your document will go to SDM. It may go to Jila Parishad. It can go to Tehsildar. It can go to many, many steps. But maybe at some of the steps, somebody did not sign. It is a fake sign. Agent will know by verifying. He has tools. He will verify. He will exactly know where to send back this paper to. So who will do all these things? You cannot do it. Okay, the agent has all these means to do it. That is what the agent will still again be doing here. It has many steps through which it will do the job. It knows how to get the driving license without driving. Okay. So it will know step by step what to do, and it can also catch which step is going wrong, and then it can also ask to redo that particular step, and from that step you can again move forward. Okay, that will be too much of an headache for a processor. A processor is not used for evaluation, self-evaluation, and then checking if the answer is how much of correct it is and all those things, right? So that those things are done by the agent. And you can match this agent with the real life agent. Exactly same. There is no difference. And in real life, you don't have just one agent. You can have multiple agents. You have asked one agent to get your passport done doesn't mean that this agent will get all your steps done. He may have his own friend who is specializing with some tax profession. He has his own friend who has connections in the RTO department. He has his own friend who has connection with the embassy. So many friends can be there. And even if the job is given to one of them, he can use all of his friends to actually get the job done. And they may together have found a company called Udyan Private Limited, right? They may set up a company together, isn't it? Why not? That is how the company is set up. Multiple directors, multiple people are present with separate responsibility. All of them are agents. But we say ECT Udyan Private Limited is a agent service. But are there one agent? Is there only one agent? No, there are many agents. Everyone has their own separate responsibility so that the work is focused. The quality of work will be better. It will be more available. It can give you more throughput. It can reduce the latency. It will give you separation of responsibility. It will give you modularity. It will increase maintainability. So many things are there. You can scale up or down only one particular use case if you want to, isn't it? If you want more people in the embassy connection, you can increase the power of that person itself. You can add up one more person for that particular job. All those things are possible only by separation of responsibility, right? So separation of responsibility is a thing where which actually lets me use multiple agents even for the same agent service. So I'll just make one box for it, but you assume that every box can have many other small boxes which are multiple agents. If you have already worked on your software engineering job designing agent, you might already be knowing that one agent is used for getting the information, one agent is used for evaluating, one agent is used for writing the test cases, one agent is used for something else, relaying the information. Four agents I named you, right? It's not just one agent. Yes.
Yeah. Surya. So isn't not similar to threads, like multiple threads, we are just doing
So
part of the process. Yeah, I mean, just trying to.
threads can do different type of job and they can also change the nature of job, but the agents
Hmm.
cannot do that. A
Okay.
driving license agent will only be driving license, right? He cannot make
Mm-hmm.
the passport suddenly,
Mm-hmm.
right? So
Got it.
the job is fixed, but there the job is not fixed. They are specialized, whereas the
Mm-hmm.
threads have no such specialization.
Right, and they can take any.
They can take
Mm-hmm.
anything, they can process.
Mm-hmm.
Also, there are many other things. It's not about processing only. It's about the brain that you have given them, what you have trained them on. Threads is like processing unit. It is not trained. It is
Mm-hmm.
not trained on anything. You have
Yeah.
created a type of thread and you just take action. So
Mm-hmm.
that is more on the hardware side.
Mm-hmm.
It is like a logical processor, right? But these two concepts are different. But yes, in one way or another, you can compare them. That yes, threads take responsibility.
Mm-hmm.
You can more. You can compare it with the course of the processor. Different cores can do different job. Again, they are
Mm-hmm.
not specialized, but still you can think in that way. Threads are logical, right? Okay, so I'll make another HLD. This is the first HLD. Again, I'll refine this HLD only for the agent. This agent service that I built and with the two, three more boxes, I have built this in 2 hours in the previous class. So you can watch that too if you are looking only for the agent details. Okay, uh, agent is there. Agent requires information about you told to get the driving license done, or maybe you want the transaction to be done. The agent should actually know some context about it. It can't decide just based on from which location and how much amount you are trying to do transaction. Because if it could do, then the ML model could have done it already, isn't it? Now, when I'm sending this to agent, I'm assuming that the ML model could not give me a satisfactory answer. That's why I'm coming to the agent. I tried to get the driving license without driving myself, but I couldn't get it. That's why I'm here, right? That's why I'm here to get the license. So now you should do something better. If you are also doing the same thing which I have tried, then what's the point of an agent? Think about it, right? So, agent, first of all, it requires the context of the events that have been seen in the past. Something which is outlier for me may be very normal for you. Let's say Rashri is traveling across the border. Okay, every month she will do some international trip. Now I am just sitting in the chair. My international trip is just crossing the road beside my society. That's it. That's my international trip, right? So if I suddenly do a transaction somewhere else, then that can be okay, a big red flag. But if she does a transaction in Tokyo or somewhere, it's normal. For deciding what is normal, something which is an outlier for somebody may be very normal for the others. You need context to decide. You can't do it just based on single transaction. Okay, that context must be saved somewhere. You have to retrieve that context. Now, let's say that you use the Dynamo to store every record, so you must be having all the context there. Retrieving the top K is very difficult from this Dynamo. You can't do top K queries on the Dynamo. You can search based on key, but you cannot search top K. Yes, you can search based on the key and you can get a lot of entries and you can sort it and you can get it's a lot of time taking process. It's not easy. What I want to see is getting the top K in less than 1 ms time. That cannot be done on Dynamo. So if you just connect it to the Dynamo and thinking that, okay, I'll get the top K from there, then that is not going to be correct. Definitely, you don't want to use heap because many of the DSA heavy people will answer heap solution that I will maintain top K using heap because that is what you have been doing using the DSA, right? Definitely, that is even worse than the Dynamo because from Dynamo you have to get the item to get to the heap. So it's easier to get from the Dynamo directly. Why you need a heap again? Okay. So all those solutions are just false solutions, though those are not going to work out. What should be the case? Where should we store? So there is a concept which I had explained in the first video.
Hierarchical navigable small world. Hierarchical navigable small world allows you to structure graphically layer wise, layer structured graphically, one layer above another. Explained you in that video which I have shared. It will allow you to explore through the galaxy and through the observable universe one exact planet in less than 1 ms time. You can think everything like a layer, all the planets of the observable universe. Then you will have many groups. Okay. Then you will have many galaxies inside the group. You will have many solar system inside the group. You can think it one layer after another, one layer after another. Keep exploring, go to the nearest neighbor, go to the nearest neighbor. And as soon as you find Earth, I was trying to find the top 5 planets around it. You can answer Venus, Mercury, and whatever, right? In the graph, exploring the top 5. That entire structure, entire data set can be kept in a so this is your vector DB. Vector DB can store your information in an n-dimensional space in such a way that if you just consider 2D space, if there is an item here, which is your transaction T1, and this is your query transaction. Query transaction means the current transaction that you want to perform. These are the past transactions T2, T3, T4, T5. These are the past transactions. Then if I ask you about the top 3 transactions, you will just look at the smallest distance 3 transactions and you will return them. Vector embedding says that, again, whatever attributes you have chosen to place these items on this vector space and dimensional vector space, you will always get, if you embed the query, you will always get the nearest neighbors as the top k. Okay, so this is what we are going to learn in the AI for SD about how do you think about all these things, right? And you see how it is related to the design. We are trying to do the design masterclass here, right? But it is also taking a lot of concept from the AI workflow, right? So I will assume that you have understood this at a high level, that you know something which is closer to a some query. I will just explore them using BFS or something, and I will just take out the items. It is not using BFS exactly, but you can think it is doing in that way. So that is called your approximate nearest neighbor search. If you so there are two options: k nearest neighbor search, which is absolutely correct, and approximate nearest neighbor search. The k nearest neighbor search will be quite slow because it relies on accuracy, but approximate nearest neighbor can trade off the accuracy for latency. So maybe if even if you are 99% accurate or 95% accurate as compared to the KNN, but if the KNN can run in 1000 ms, then the approximate nearest neighbor can run in less than 1 ms. So if this is 95% accurate and if this is 100% accurate, I think it is very, very reasonable to take the NN approach, isn't it? 1000 time improvement on latency with 5% hit on the accuracy. Why don't we take that? We will take it. We will take the NN approach, okay? So we will be taking the NN approach. Fine. Where to keep such kind of information? We cannot keep it in Dynamo. There is a specialized DB not coming under SQL or NoSQL. It is called vector DB. Nowadays, that support is given to SQL as well as NoSQL, but previously it was like a separate thing. Okay. So let's say you have kept a vector DB somewhere, which will be storing all these n-dimensional embeddings, vector DB, and it will try to retrieve from here. But the agent will not take all the responsibility of getting this top K. It will have a retriever service in the middle. Retriever service. Okay. So let's make it retriever service. What this agent will do is it knows about what to do. It will take the query. It will try to decompose this into subqueries. The agent will take a query. It will make multiple subqueries S1, S2, S3. If you say that if your query was whether my transaction is fraud or not, just tell me. It will convert it into a subquery. I am making a transaction from New York City
I'm making a transaction of $500. I'm paying to such and such website in Taiwan. These are all subqueries. This is giving more context and giving it in a more organized way rather than just saying whether my transaction should pass or fail. So this is called intent derivation. This is shown in the pipeline of the previous class, the video which I have shared. Okay, the intent derivation, query analysis, subquery formation, and then each of the subqueries, how it is going to be processed. So here we are designing something else. So we will just keep it very high level. Okay. So the agent service is connected to the retriever service, and the retriever is connected to the vector DB, and vector DB will be used to pull out the top k based on the approximate nearest neighbor. So I can say that this will pull out top k ANN based top k, approximate nearest neighbor based top k. Okay. What should be the next thing? When the data is retrieved, then what should the agent service do? Anyone? When you get the data, then what should the agent do with this?
LLM call.
Okay. LLM call. We will try to refine it in some time, but let's say that you know that it is going to do LLM call. So let's make the LLM here, LLM service. LLM service, has it got the context? Yes, it has got the context, top K context, or top K embeddings, or top K information, whatever you say. Top K has been given to the LLM. LLM will do its own scrutiny and will present the output to the agent service. Fine. I think I should refine it here only. I will just expand this. I will rub it and expand, but let's try to understand first with the smaller diagram. Retriever is told to get the top K. It got top K using ANN. It has sent the information to LLM. LLM has done its own scrutiny and has sent the information to the agent. Then the agent can say, based on the LLM's context, whether it has passed or failed. Okay. Now you tell me, okay, let's say it is all fine. You tell me if your transaction is under processing, that circle is going or maybe some pipe is moving. Don't you want, you become anxious until it is done or it is not done, isn't it? Something is written. So shouldn't there be a flag, state flag, which says passed, failed, or processing? So that if it is the pipe is moving, it should not move indefinitely. How should I implement it? Because I said some transactions can take time. Your pipe cannot keep moving for 15-20 seconds. You should say that it is under processing stage. And then you know that, okay, the company guys told me that it can take 20 to 30 seconds if it is under processing. So I can wait until then and then everything will be sorted. But if the pipe keeps moving, that doesn't give a good quality of service. Because
Payment.
people tend to just cancel, tend to come back where it is not cancelable now. It should, the cancellation should be possible, right? But if you are into this loop, then you cannot cancel it probably. So there should be some state management, as I said.
So is it should go to the pending state and just
Yeah,
say,
pending state. But who will maintain that state? Is the DynamoDB maintaining that state? It is a low latency state management, right? DynamoDB is not low latency state management.
Redis in between.
Yeah, now you can go for Redis, isn't it? Because
Hmm.
Redis is in memory. In memory DB is something that you looking for KV pair, probably. You can go for Redis here. Redis state management. And immediately as soon as the request comes in from this suspicious check, immediately the agent service can set the flag it as pending, can start the process. It can take 10 second, 15 second, and then it can reset the flag to, let's say, pass or fail, isn't it? I think that should be a reasonable design choice.
Reset means update, right?
Hmm?
Reset means you are saying the status will be updated
Yeah.
after.
Yeah.
Hmm.
Reset means it will be updated to either pass or fail, whatever is the decision taken at the agent service, right? State management is done. And also the agent will be notifying this notification service what was the outcome. So the notification service can take care of it. Fine. So now we have also solved that problem of maintaining the state and changing, transitioning the state at low latency. That is done with Redis cluster. Okay. Now there is another question from me. That question is, if let's say, I mean, anyway, Rashri was traveling, right? She was traveling internationally. Who will maintain that state? Is Dynamo maintaining that state? Is Redis maintaining that state? Or some other DB that you will introduce will maintain that state? Because it needs faster replication for a certain selective candidates. Who will do that? Faster replication. First of all, think, is it for durability purpose or it is for latency? Durability replication is already happening for everyone across Dynamo. So I don't need for durability when I say that I want it to be fast. I am looking for latency. And what should be my option? Should I introduce another DB to it? Or should this Redis take care of it? What do you think?
Redis can take care.
Yeah, Redis can take care of it. It can be a global cluster. Redis can maintain global cluster. It can do global replication too. So there are options in Redis to do that. And definitely Redis can do this. So it cannot just do state management, but it can do user uh, immediate context management or immediate context management, or you can say the recent history. Recent history can be stored. So let me write recent history. That would be better, isn't it? Recent history can be maintained. So this Redis is doing multiple things. It is one part of it is doing the state management. Another part of it is doing, when I say one Redis node, it is a cluster. It is a Redis cluster. And each of, and state management node can be something different. It is a physically separated node. And the recent history management is a physically separated node. It's not the same node who is doing all the job. Okay. So uh, you can follow the Redis class. There I have explained everything, like how the cluster works and how they are separated. But I think it is reasonable, right? That I will do separation of responsibility across physical nodes, state management and recent history. What else? Yeah, Rakesh.
So then have a international travel card, but haven't traveled for 1 year. Then for first
Uh,
time, it will take some time, right? To get it
yeah,
updated.
yeah. If you have not traveled, it is not replicating. So when it is not replicating, and if you are trying to do transaction, then it will try to retrieve your past information from the vector DB, because then you cannot just check from the Redis. Redis do not have that information. Redis knows
And
that Redis may not have been replicating your information because you are not traveling. Then the agent service might flag it like an outlier. There may be a decline in your transaction for the first time. That is one thing that may happen. Or if you are an international card holder or something, then potentially you are a traveler even though you have not traveled. So there can be another flow for it where it tries to retrieve global information. That when the retriever service works, it doesn't just work on the vector DB, but it tries to see the global state, that have you traveled. Yes, it can get declined for first time, but if you are a card holder which can actually do that, then there can be a double check or by call or by message or something like a two-factor authentication type, where you get a call and select one for, let's say, whether you want it to pass or want it to fail.
yeah,
Okay,
but
so
after
those
that, it
checks are
will.
outside of this. Yeah,
Yeah.
after that it will be in the Redis and it will know about it. Only for the first time you can have friction, but I think that is reasonable, right? Or uh, you will be setting the state in your company. Company means in your bank company, that I need a card because I am traveling outside. Because when you are traveling outside, you will be prepared for what type of currency I'm going to use and how will I transact. So maybe you will be providing that information, or already you might have communicated. Whereas if you have not communicated with some bank, if they are supporting forex transaction or international transaction, then you might run into this thing where you might have to do double verification. Okay. Okay. So that is outside of this. These are just automated real-time auditing. Then the authentication design is different. Authentication comes, it can come parallel to this as well. As soon as the ML model gives an output, an authentication can also be triggered from here. That while the agent is working, let's give them a call as well. Side by side, human feedback is also taken, right? You can do RLHF type learning. You can do human feedback learning. This agent and LLM is doing its own part. But you will see that even in the LLM, there are sometimes feedback options, option one, option two, and select which option seems better. That is based on human feedback, isn't it? So side by side, you can add here a component for that call service. Call or two-factor authentication can be triggered if it is in the gray zone. So what is happening? Since this is taking enough time for two-factor authentication to get triggered, enter the OTP. It is asking you to enter the OTP. It is wasting your time. But meanwhile, it is also doing its own research and it is also engaging you, or it can give you a call immediately, automated call. So that two-factor authentication will verify. If two-factor authentication do not match up with the agent output, then it will block immediately. Okay. So it can take strict action. It can have more priority for 2FA. But if it thinks that 2FA can fail, then it can have more priority to the agent service, or it can block altogether if both the options are not exactly matching. Agent's output and your output. Okay, so that is your choice to add. But in this design, we are not moving into that flow. Otherwise, it will take a lot of time, right? Yeah. It is a separate discussion. But anyway, I think it's a good question. So you can add it.
But just simple question. So is it good to have agent for this two factor? Currently, I don't think we
No, no,
have.
no. You will not have agent for everything because the thing is, you want to include that human feedback factor as well. So I think that it makes sense to engage and take a 2FA rather than again having an agent for it.
Okay.
Because agent will require data, but human feedback do not require any DB. It just requires a call or OTP, right?
Right. Okay.
The main problem here is to maintain the state, and where is that state? There is no state for it, right? And that is why the agent was failing it. But two-factor authentication is a different type of output or an input-output flow. So it's a good flow actually. It cannot be replaced by agent. Okay. Whereas it can be complementary with the agent. So we can add it. Fine. So let's add it to FA. And there should be some kind of a decision maker in the middle who sees the agent's output and the 2FA's output. Let's not make it more complex. Already it is going to be so complex, right? So yeah. Anyway, so up to what point have we seen? We have seen the recent history management and the state management. Fine. Okay. Now think about in improving the accuracy on this design. Let's say that this design should work fine. But if you want a higher accuracy, maybe the top K ANN is not giving the best possible top K. Maybe this is giving you top 50. Whereas the LLM, if it starts working on 50 output, it will take huge amount of time. Maybe the LLM doesn't want to see 50 output, but it wants the top five most high quality answers, or maybe the high quality embeddings from the vector DB. What then? But the ANN cannot just say the top five are absolutely the top five. So there has to be somebody who does some kind of rearrangement of this top K. When you say top K, it is giving a sorted top K already. But this is approximate nearest neighbor. It is not the same as K nearest neighbor. So it cannot just emit this top K content to the LLM service. That will not be a very good design. It can take more time to process because LLM should take high quality, less context because it takes more time to reason. Okay. So keeping that in mind, we will have a re-ranker in place. Re-ranker. What the re-ranker will do is it will take the top K sorted, and it will give top, let's say, top five only, top five to the LLM service. What this re-ranker is doing, it is just taking top 50 and it is working on only, let's say, top 10, and it is, or let's say top 7, it is just doing job on top 7 and trying to re-rank them based on more refined features. What exactly do you want? More refined features are added. Okay, what exactly do you want? And based on that, the rank 1 could have moved, slipped down to rank 3. Rank 3 could have gone to rank 2, and some rearrangement will happen. And after that, it will trim out the top 5 and return to the LLM service. Have you understood? Because approximate nearest neighbor was just based on the vector space, and the vector space is designed based on n number of attributes in n dimensional space. But you can add more refinement to those logic in the re-ranker, and it can emit the top 5 or top n, whatever you want, to the LLM service. LLM wants less number of high quality input so that it gets less confused, and it actually does more amount of work in reasoning and have its baseline facts in place. Yes, Nitish.
Surya, my question was about this. So all the events which are coming from Kafka and then getting flagged from ML model. So all events will go to DynamoDB, or only suspicious you have put
No, every event
suspicious
will go
or
to Dynamo. Every event will go to Dynamo. And as
oh,
soon as
so
some, okay, so this will also be writing to the
yeah,
Dynamo.
this one I'm
Okay. Yeah, this will also update. So this will be updating, and that
update.
would be writing. This would be write, and that would be update. Because even if it is in the suspicious, the state will be changed by the agent when it actually makes a final reset on the Redis. Okay.
Yeah,
Okay.
yeah, got it.
So I think the now it is a cleaner type of design that a re-ranker is present. If you want to learn about these four, I have already taken a class, 4 hours class on this. I mean 2 hours class on this in the hallucination class last time, which I had taken. Entire pipeline have been explained. Okay. But I'm just giving you a high level overview. A 2 hours class was done in the design class on vector DB that you might be aware. Okay, so each component has its own class. If you want to learn about Kafka, it is already uploaded on YouTube. It is a 3 hours, 30 minutes class on Kafka. A Flink has its own 6 to 7 hours class. So each of them has separate classes. Okay, so here we are just trying to combine them together. I think this flow makes a lot of sense right now. Then I will move on to my asking my next question. And my next question is, how will the agent know that the result of the LLM is a good result or not a expected result? I said that agent has this special power to see what is wrong with the output. Is the driving license correct? This name looks incorrect. This driving license looks a forged one. It is not correct. This sign looks forged, right? So agent knows about this because he is doing it daily. But here how the agent will do? He has to do some kind of evaluation work, right? So the agent's next step number 1 was this, setting the Redis. Step number 2 was the retrieval service. Step number 3 is the re-ranker. Step number 4 is the reasoning. Step number 5 is self-evaluation. So you see, this self-evaluation job is not the same as setting and resetting in the Redis. So when the jobs are different, we will take two separate agents for it. Agent service is a playground where agents can work and thrive. It is just like saying, I have a pool of processors or a pool of threads, and you can use the threads to get your job done. So the threads, if I have 1000 threads, that is an agent service. Each of those threads will be taken by one agent, and they will do their separate job. So when I say agent service, it is a playground. It is not an agent. And where agents will come, different type of agents will come and take some space, consume some space there, and try to do their own dedicated work, just like how threads are designed, isn't it? If you have 128 threads, different type of job will take one or two threads, some threads, and will do different jobs. But the entire playground is called processing unit or something, the thread pool, and here it is called agent service. So thread pool and agent service can be compared, okay, logically compared. So agent service do not mean one agent. It is like a playground where agents can work. Some agents and each of them can be separate agent.
So one of that agent is a self-evaluation agent. It has a dedicated job of getting the LLM output and finding out if there is something wrong with any of the steps that we have done, step 2, step 3, step 4, and should we go back to certain step, or uh, the answer is fine and I should reset the Redis. But how will it know about it? If you ask me, like, how will it know about it? So even every company have their own set of policies. Policies means somebody who is just a zero balance account holder should not be able to transact more than $5,000 in India in a single transaction. Maybe somebody who is doing international transaction on a money back card should not be able to spend more than $1,000. These are hard coded rules. Maybe these rules are set not just by company but by you, by going to the net banking, going to the card account, and then setting a limit for yourself that I will not spend so much and so much, right? For safety, so that you don't lose money. You know, these settings are available, right? Where those settings are present, those settings are again present in configuration and is present on the Redis. These are all config settings. Again on the Redis. It is replicated everywhere. The users who are traveling, their configs are also present, or maybe company-based config, default configs are present as well. They are not big in size. All these are small in size, right? So they are on the Redis. So this self-evaluation will extract the config and will try to do rule-based matching. So this can be considered like a rule-based engine. So let me say this is a rule-based engine. Rule-based engine was something like Siri. If you ask something, you get exact same output. Google Assistant is AI powered engine. Siri is a rule based engine. You will find immediately what is the difference between them. You use them, you will find the difference, isn't it? Gemini is a AI powered engine. Again, Siri is a rule based engine. You can't tell a rule based engine to do something innovative, something which takes brain. Rule based engine is like a simple KV pair where if a certain rule hits, if you ask me the meaning of something, I'll tell you. And I will search through internet, I'll tell you. I'll do simple tasks, but my answers are guaranteed to not hallucinate. Rule-based engine will not hallucinate. Rule-based engine will not reason anything. Rule-based engine is seeing a value, it will try to say whether I should do it or I should not do it. It is like a hard code follower of somebody. Whatever he does, it doesn't matter. I'll just follow that person. Whatever he does. That is a rule-based engine. Whereas an AI powered engine will apply its own brain. Something like LLM service will apply its brain, do contextual analysis, everything it will do to find out reasoning of why, if I'm taking an action, why should I take it? It will do step by step reasoning, isn't it? So those who can do reasoning, those who can do logical deduction, uh, malformation of answers are possible there. Maybe you think I am very logical person unless your mind has been brainwashed in a way that is outputting some result that is not a good result. Okay, many logical people will be giving such answers which might not suit what you think is right. What you think is right may not be right for somebody else. Somebody else will think that you are hallucinating, whereas you think that I am right and that guy is hallucinating, isn't it? On the same agenda. You might have two different opinion and both have their own logical baseline for it. And something that is a good answer for somebody can be hallucination for somebody else. So when I say hallucination, it doesn't mean that it is always wrong. It means that it is not matching my expectation. Why, whereas that answer could have been a better answer. But since it is not matching my expectation, I am telling that as hallucination. Hallucination doesn't mean something is wrong. So think about it. If I have these configuration settings and rule-based matching, rules are present in Redis, can be extracted by the self-evaluation agent. And if they are matching it, then they can give a final verdict on whether something is passing or failing based on those rules, isn't it? That's how they can decide on whether some work has been done good or needs more refinement. Self-evaluation engine will also find out which step might be wrong. Maybe you are asking for whether I can do these transactions or not, and it is giving you a vague answer.
you can do this under this condition, cannot do under that condition, this and that, and it is giving you a sentence answer, which you cannot evaluate, or maybe which you find that it is a nonsense answer. Then the agent will be trying to find out in which step I should go back to refine an answer or to get more accurate answer. Maybe I should also put a query, like you might have already seen that you are asking a question on GPT, it is giving you some theoretical long answer. Then you will say that please tell me point wise, point one, point two, point three, like that. Or if you were studying some comparison, you will ask that, okay, please make a table and show me in brief the comparison between two items, isn't it? The GPT will not know what to do until you specifically say. That is called few shot learning. So GPT works best if it is given a few shot learning. Few shot means you give one shot, two shot, give examples, then the GPT performance will exponentially increase. Those kind of things and architecture we will see in the AI class. So that is where we will understand like why few shot learning is required, why is one shot learning or zero shot learning is required, what is the difference between them and how it can improve my design. But I'm telling you that here few shot learning can be done. The self evaluator will find out which step I should go back to. Let's understand it at a high level because this is not a part of the design class anyway. And it will send back to that particular job. Like let's say the query, intent analysis was not good enough. Then maybe there will be another agent for intent analysis. That agent will be called and said that, you again do the intent analysis and then the subqueries will be built and then the top K can be retrieved. Whereas if it finds that, the intent analysis was good, but the subquery formation was not good enough, I have to be more precise in my subqueries. So it will say that, okay, when you are comparing two things, you also include the bullet points, you keep it short, you keep it concise, you keep numerical numbers. You don't give me vague English numbers and reasoning for it. Or if it finds that, top K was not good enough, so it will ask the retriever service to get the top K again. Or if it finds that the re-ranker didn't do a good job, it will ask the re-ranker to again re-rank the past retrieved output. And it can change the parameters, that these parameters are my goals, important parameters. Maybe the reasoning was not good enough. It can ask the LLM service to refine the answer. I didn't mean actually this thing, but I think you focused on some other things. I needed to focus on some other things. That the agent should say. I think you might have already used such kind of things, right? You are asking something, the answer is coming something else. So then you refine that, okay, I was expecting this thing. Then maybe you will be getting a better answer. So that will improve your design. So we know many agents are present here. We have done the state management. We have made this pipeline. Again, this detailed pipeline, repeating that it is present in another class. We have stored all the transaction record. We will update it. We will send it to the notification service and that should be done. Right? That should be done. So when I use an agent for retrieving the information, from a vector DB or some DB. Generally, we will definitely use vector DB. We used to retrieve information. We reasoned based on this retrieved information. Then what we are doing is we are generating answers based on the retrieved information. And whatever answer that we are building, we are providing reference of that answer. That means we are augmenting the answer with the references. Whenever we are giving answer, we are augmenting. That means we are referencing, putting the reference. Point number one, link number one. I have put this sentence from link number one. Click on this link to view more. Okay. So we are augmenting our result from the we are augmenting the generated result from our retrieved answer. So it is called retrieval augmented generation or your RAG. This tries to uh, bring the LLM service in place of reducing the chance of hallucinating, because you have to always give answer based on the information present in the DB. You cannot go outside of the DB's information. And here, the agent service, we are just saying that something looks suspicious, but the agent service is the one who will be deciding, okay, what is the exact goal? It will be deciding what should I query to get to that goal. It will be deciding all the step-by-step flow. It will be deciding in each of the sub-step what should be the answer that I'm looking for. And it is trying to orchestrate everything until you get to the final result, also doing self-evaluation and again redoing some steps and again coming back and self-evaluating. This is an autonomous process. Nobody is driving this. We, as a user, nobody is driving this, right? Neither the software engineer nor the user, nobody is driving this. This is autonomously done. So when an agent autonomously done is doing the work, it is called agentic AI. Agentic AI is when an agent does the work autonomously. And when you have a baseline fact attached to it, where you have to put the reference of everything, then that becomes agentic AI with RAG, or you can in short say agentic RAG. It is not called agentic AI with RAG, but it is called agentic RAG, right? So can you now compare where do they stand? What is agentic RAG? So you can say that if this is agentic AI, then this is your agentic RAG, because agentic AI is something which where an agent autonomously does the work from entire planning, query analysis, whatever. But RAG is you do all those things. Along with that, your answer should be having a reference from your own DB, shouldn't be going elsewhere. So now you are becoming more and more focused in your answers, isn't it? You're becoming more focused. So that is where the agentic RAG comes into picture. What is a RAG? Now, RAG is not the same as agentic AI or what. RAG can be without agent too, retrieval augmented generation. It may be done by the software engineers. It may be done by a bot. It may be done by somebody, rule-based engine too. So RAG stands here. Okay, agentic AI stands here. Agentic AI. And the agentic RAG stands here. So agentic RAG is a RAG system which is done by an agentic AI. So is it a subset of the agentic AI? Yes. Is it a subset of the RAG? Yes. And they have a common intersection point here. So this figure is also correct that agentic RAG is a subset of agentic AI. So yes, agentic RAG is a subset of agentic AI. This entire part is RAG and this entire circle is the agentic AI. Whereas all the RAG is not agentic because agent may not be present. Are all the agent service also agentic? No. Agent service is not agentic, and you can have agents covering all this part as the agent service. Agents may not be just AI type. Okay. Agent service. It is like a playground where AI type, non-AI type, rule-based type, everyone can be present there. Hard-coded type. Okay. Agent do not mean everything is AI type. So we have understood, I think, in quite a bit of depth. Even if the question changes, I think you can handle it. It's not like you are not going to handle it, right? Okay. So we have seen the entire HLD of the fraud detections design with a high recall value with real-time auditing. Because what is auditing? Auditing means why this has happened, why that has happened. All those things the whys should be answered, and that the LLM service is already doing. So this is called your real-time auditing, right? Now let's discuss about the bottlenecks in this design and how to get around that. Uh, your Kafka can become the bottleneck in very high scale design. But again, Kafka is very highly scalable too. Okay, if you have watched the Kafka video, you might have seen that it can actually scale a lot. It cannot add a lot of nodes in its cluster. So it's very highly scalable. So you can just keep adding the values. But let's say that adding horizontal scalability, okay, it is supported by Kafka, but I will try to perform as many transactions as I can with the same, same resources. Because definitely with more money, you can buy anything. But why should I spend more money when I should try to get the same thing at a lower amount, isn't it? That is what should be the goal, even though you have a lot of money. Still. So if I keep that in my mind, I don't want to waste resource. If I save resource somewhere, I'll use it somewhere else. Using more resources more costly. Your pricing will increase. Your cost will increase. Where will you take back this cost? You will ask the customer to pay somehow infrastructure fees or something, right? And if the customer is paying more, then maybe the customer is less likely to take your infrastructure. Maybe if someone else is offering the same thing at a lower price. So that will affect your design. Your business can get affected. So keeping that in mind, can you tell me what should I do with the Kafka or with the Flink so that without increasing horizontally, without scaling it, how can I increase the throughput or how can I take more load? Rakesh, you are not putting your hand down.
I have another question, that's why.
Oh, you have another. Okay, I thought you forgot to put your hand down. Okay, tell me.
So in the previous slide, sorry, not this slide,
Hmm.
re-ranking on what you mentioned parameter, right? So where exactly we save parameters, on what parameter basis the retrieved augment data will be re-ranked?
What should be the parameter?
Yeah,
Okay.
yeah, like
I
here,
think you can, yeah. So I have did explained this in detail in the last class.
yeah, yeah,
So
but
you
we should
can
have
follow
some
that.
mechanism, right?
But I'll tell you that the approximate nearest neighbor is taking the input. If you go back to that class, I have explained inverted file indexing too, uh, and all the other techniques, centroid-based technique too, how it retrieves the top K. Based on that, the re-ranker may still work on the same parameters, but it is not an approximation anymore. It is a accurate result now.
Okay,
So even though the parameters do not change, still an approximate top 5 versus the actual top 5 can vary, isn't it?
okay,
So now I'm not doing for speed, I'm doing for because why I needed speed in vector DB? I have a lot of points, billions of points. In that I cannot do matching. I have to be quick at retrieving the data. Now I just need to compare the top 40, 50, or maybe top 10 only. Even though 50 sorted are coming, I'm just taking top 10 and re-ranking them into top 5 and then trimming top 5, right? So data points are very less, so that even if you do accurate re-ranking, still you will do it in very less time. 1 billion point comparison and just a 10.5 point comparison is a no match, isn't it? So I can do that. Even if I don't change the parameter, I'll get to change everything. If I say that Udyan got 80 in chemistry, approximately, Rakesh got 90 and Nitish got 95. Maybe Udyan had got 83. Maybe Rakesh has got 82, where I was assuming 90. Maybe Nitish has got 87. It may affect your ranking when you go to the exact numbers. Maybe everyone got 82, but somebody got 82.1, somebody got 82.5, somebody got 82.4. And this was rank 1, rank 2, rank 3. After re-ranking, you will get this to rank 1, get this to rank 2, and get this to rank 3. Because maybe in the calculation, you didn't take the decimal into account, floating numbers into account. Many things can happen, okay? So the thing is, even if the parameters don't change, still, you can re-rank, but you can also change it. You can add more parameters to it as well. And this has been explained in a data pipeline in the last class, hallucination class. You can just rewatch it. I have already shared the video in the group. I think you just got added right now after the class started, right? Yes, Rakesh. Okay. So yeah. So coming back to my question, what would you do here without doing horizontal scalability?
So we can go for batching option and trade off on latency if possible, and
No, no, that is
can
not possible. That is not possible because transaction we want to reduce latency, isn't it? We want low
sure.
latency here. The batching or micro batching is not possible. Okay. I don't want to give 5, 10 ms more to it.
Hmm.
Not just 10 ms, it can be like 100 ms if you start batching it. 100 ms, 500 ms more addition to it. I can't give it here.
Hmm.
Any other technique?
We
Uh,
can reduce shuffling in Flink.
Shuffling in Flink, yes, that
Yeah, similar
can
data
be
to
one
the
of the
same node.
strategy, but how we will do this? Shuffling the shuffling the nodes. That means if you have already watched my class on MapReduce, Flink also uses MapReduce. In MapReduce, after the map phase, when you move to the reduce phase, there is a global remapping of the items. Similar items will go to the same location, isn't it? So I said back then that if you map it logically in such a way that similar users go to the similar location, the remapping load will be less. So in the map reduce function, your reduce will do less remapping, and so less lower, it can lower the latency somewhat. So that can be a good point as well. Lower remapping, or you can say smarter map reduce. Smarter map reduce means what? I mean, how will you implement it? It is not the algorithm that is changing. Okay, so I should not write smarter map reduce. I should say that similar user should keep going to the same worker node, because Flink is a stateful processor. Anything which is stateful maintains the state of a user. You should maintain the state, you should keep the state, you should keep sending all the information to the same place. If you don't know this, you can just think about TCP. TCP connection, if you set it, it is best that you keep it set and you keep transferring rather than set it, unset it, set it, unset it, because it requires handshake and tear down. Even in DB, you set up a connection with a DB, you keep sending the data. That's why batch write is faster than one writes, because there is a latency involved in setting a connection to the DB and tearing it down. Same thing goes for TCP as well. That is why we don't use TCP for live streaming, right? UDP is used because there is no setup cost. But because it is not stateful, TCP is stateful. In this case, Flink is stateful. So you want to send the same user to the same worker node. How that can be achieved? Who knows about all these things? Though those things can be done from Kafka. I answered you in the beginning that Kafka partition, same partition will be sending to the same workers or a group of workers, so some subset of workers. And the Kafka partition can also logically maintain using Zookeeper. Zookeeper is a wait-free coordination, right? If you have watched my class on Zookeeper, you will know that Zookeeper manages all these who will go where. It is a cluster manager. Okay, Kafka is a store. It will know who has subscribed, who are the consumer groups, where should I send. So the same partition will most likely should send to the same worker node until the worker node is down. You can have more than one worker node to which it partitions, to which it sends, but it will send generally to the same worker node. So can I maintain that the same user goes to the same Kafka partition so that it goes to the same worker in the Flink, and so the context loading is less, context reloading is less. So same user going to the same Kafka partition, and this leads to the same Flink worker. And this leads to less context reloading because everything is stateful here. So see how everything is connected. Context reloading reduces. Okay, if you send the user request again to some other node in the Flink, again it has to load everything right from scratch. So it will be again too much of work. Okay, so you can reduce latency here. Okay, so this can be set like a smarter kind of a map reduce. Yeah.
And to on for the Argental scaling, I think we can create more partitions to reuse the
No, no, that is
resources.
fine. But I was saying that we do not want to do horizontal scaling. That will increase the cost as well as soon as you increase the machines, right? We can do horizontal scaling both in Kafka and in Flink.
No,
But
I
I'm
mean
saying,
avoid Argental scaling to
Hmm.
reuse more Kafka resources. I'm answering that first question. You are asking like
Hmm.
how can we avoid Argental scaling, right? Can we increase more partitions in the Kafka and then
That
those
is scaling only, right? If you increase partition, then that is scaling.
scaling? Okay, okay.
Increasing partition means increasing the nodes in the cluster, isn't it?
Within
Right.
existing itself, can we increase more partitions?
You can give options. You can give option and increase it. You can give whatever size you want for the partition to.
Okay.
Okay. So anyway, my goal is I have given a high level goal what I want to achieve. Now you can achieve it by giving a more granular level of partition is I think what you are trying to say. Not a big partition, but a smaller and more number of partitions so that each partition maps to one of the worker nodes that you can try. But implementation is up to you. The goal I have set. Another thing that we can do.
Checkpoint.
Hmm?
We can increase the rate of I mean snapshotting the checkpoints.
Okay. So we are into the next question now. So let's keep it to this part. Okay. Uh, Next question, second question. Or I can say that second way we can improve the design is to rate limit everything. That is done. You can't use the advanced voice a lot. You can't use GPT, keep on using GPT. You can't use anything above a certain rate. So rate limiter will come in this design somewhere, right? Think about if if there is a Black Friday spike in the transaction, and if more than 1% transaction, or let's say even 1% is coming, if the transaction have become 10 times, it will put a lot of load on the LLM service. Then it can spike up your waiting time a lot. It cannot just be 10 seconds. Now there can be waiting time too. Maybe the LLM service is not available because it is already loaded with a lot of work. How will you handle that scenario? Rate limiter is one simple approach that whenever you send request, you can't keep on sending request, tap on send, and process. There must be some exponential backoff algorithm. If you implement exponential backoff with rate limiter, I think you can do things better. Exponential backoff can also be implemented in something like TCP connection. You might study it in networking. Okay, if something is not working out, congestion is happening, then how will you actually, if there is a network congestion, can you just keep trying? That will just add up to the congestion, isn't it? So you should exponentially back off. That means first time I will back off in for 2 to the power 0 second. Then I will not do anything for 2 to the power 1 second. Then 2 to the power 2 second. Like that, in power of 2, you are increasing your gap for the next retry. That is exponential back off. Okay. Every time you get hit by a block or a congestion, or your packet drops because of congestion or something, you will wait for longer. If it keeps happening, it is just like the probability formula, where probability of A, B, C happening with D is a multiplication, and it will exponentially decrease your probability of all the events happening together, right? If I ask you probability of Rakesh eating rice today versus probability of Rohit Sharma eating 100 and Rakesh eating rice, isn't it? So which one will be having higher probability? I can again club together that Nitish getting a job today as well as the third probability. Then these are non-related events, and so probability can be like exponentially decrease, right? Depending on what we are seeing. So anyway, coming back to this design, I think rate limiter can be thought of like a fallback mechanism. If nothing is going right, maybe you can have a reasonable rate limiter with exponential back off. Okay. Then we didn't discuss one more thing about the Redis. What should be the eviction policy in Redis? Because I am taking it like a cache, and there must be a cache eviction policy, LRU, LFU, whatever. When will I say that I don't need something and I should remove it?
because Redis is not very large. It is in memory is what I am assuming. Dynamo is the larger one. So when should I clear the items? What will you answer for this? Actually, you should be answering for this.
It should be decided by business. Some days, 30 days or something.
If it is
It
not
should be decided by business. Okay.
if it is
Uh,
not active for so many hours or some.
Yeah, if the user is inactive from past 1 month or something like that.
hmm. Okay. So I think you can say that when the transaction passes or fails, I'll just remove it. I'll remove the state at least. So there are many things that are stored. Config I will continue to store until you go to your net banking and change the config. Your own config will be stored. The hard coded company policies will be present always. It can only change, it cannot be removed until the company removes it altogether. So some things may never be removed. That is the configurations. But state management can be very volatile. As soon as you come to pass or fail from processing, you can remove it after writing, after the write has been done to the Dynamo. Okay. And I can say that, okay, 5 minutes, within 5 minutes, I will remove, definitely I'll remove the state management. Because anyway, I was just going to answer in 20 seconds, 15 to 20 seconds, right? So 5 minutes is a is a big enough timeline for the transaction to either pass or fail. So I will remove that state flag, right? So that is the state management. Recent history. How much recent history should I keep so that those data may not be replicated fast enough to the DB, but it can be replicated in the Redis. I can maintain for 1 day, 2 day, 3 day like that, or maybe 1 week. Okay, for the traveling people. So this state management can be kept for let's say 5 minutes. Recent history can be kept for let's say 7 days or something. Because within that, the Dynamo and other DBs will be having the vector DB itself will be, replicating the information. So why I'm keeping recent history here. Maybe those history is not available in the vector replication, right? Maybe it is not fast enough as the Redis, how fast the Redis can do. But vector can still do within 1 day. So I can also say that, okay, I will not maintain more than 1 day. 1 day immediate recent history I will keep in Redis. Or if I want to just be overlapping, I can keep 7 days. Okay. Now you think about one major flaw in this design. One major flaw is the vector DB is not getting updated. Who is updating the vector DB? Nobody is updating the vector DB, right? I'm just assuming it gets updated, but somebody has to update it. Vector DB should be updated with all the events that is taking place. So there must be some processor which pulls the transaction record from Dynamo, puts it under the vector DB in the form of embedding. And how this process happens, we will explain this in the AI class, like how your transaction gets converted to vector embedding. Okay, so there are 5 steps to it. It is an entire pipeline how this happens. So that is a separate thing. So let's assume that it is happening. Now there is another flow that we need to take care. Another flow is agent service. When it decides on some suspicious event, can that immediately be also updated in the vector DB through another path? Yes, this can actually update it here, vector DB, directly while sending the uh, update to the notification service. It can also update that the suspicious activity which was running has passed and only the past information can be updated. Failed information I'll remove because when any top key has to be searched, I'm not interested in the failed transaction. I'm interested in the past transaction. Okay. But what if I'm interested in also the failed transaction? Then what to do? I'll maintain it under the Dynamo. I mean, Dynamo will maintain all the transaction, pass, fail, whatever. And that will be helpful in training the ML model because ML model would require retraining. Coming to the ML model, how will it learn? How will the ML model learn? There can be ML model number one, and there can be some separate ML model on the back end, which will continuously get trained from the last day's transaction record using batch processing model. And every day the ML1 will get replaced with ML2, and ML1 will come here, and this will get processed with, trained on the last day's transaction record, and the next day ML1 will come and ML2 will come here. So what I'm trying to do is the ML model is trained only just for, it is not trained for the current day, but up to the last day, it is updated with all the learning for all the users and all the type of transaction pass or fail. Understood? So that's how I can keep replacing the ML model every night. And I can keep doing that using the batch processing from the transaction record. That can again be a separate flow. Okay, so that is a batch processing work, and this is a stream processing work. Fine. So I think pieces are in place now. What do you say? How do you reduce the vector DB latency? Definitely, I'll be using HNSW, which is very highly scalable and a sub MS ANN search engine, or the search algorithm, I should say, not engine. How would you compare the trade-off of cost and latency? Cost versus latency, or let's say cost versus accuracy. If you want higher accuracy, your cost is going to increase. Higher accuracy means what? You are going to send more and more records to the LLM, the agent service. And so it will require more scrutiny. It is going to be more accurate, but the cost on time and computations are going to increase, both time and computation, resource and computation. And it is going to give less quality of service, because at the end of the day, user just want to pass the transaction. That's it. Fraud can also be one of the parameter, but most of the people will actually care about whether the intended transaction is passing or not passing, or how much time it is taking. If you compare the latency with UX, user experience, latency increases, user experience decreases, and latency will increase when accuracy increases, right? That means you get higher recall. So you have to find the balance. When you compare complexity with maintainability, when complexity increases, maintainability will decrease. It will be very hard to maintain. Complexity will increase when you want higher accuracy, and latency will also increase, right? Because so much big HLD. If I had not given all these things, it would be so much easier. Since you have added agent, you are taking so much of time now, isn't it? So much of time. So that will take extra cost. So these all trade-offs you can discuss, or you may be asked to discuss. Now, keeping the staff engineer level in mind, or senior engineer, what would be the future scope or future improvement on this? Future improvement on the entire overall design. You can say something like, we are discussing the suspicious transaction, but one of the things that we can do is find out the find out the ring of fraud, or the fraud ring. Fraud ring means some people who runs this fraud as a business. Okay, in India you will find a lot of those groups and companies that they will maintain something like a call center and keep calling and doing all these kind of scams, right? So some kind of ring can be present. One person is having 10 different mobile phone for doing all these kind of transactions. So if I am using some kind of graph DB, which can maintain relationship, where I say that in this same mobile number, or in this same account, I am having 10 mobile numbers, or at this same device, I am having 10 different accounts, accessed 10 different account with the same MAC address or something. Then the graph will say that this is highly likely that it is not a normal user, must be a scammer. Okay, so I cannot just detect whether the current transaction is a fraud or not a fraud, but I can also detect the ring of fraud as well, the fraud rings. Okay. If you had not said about HNSW here, you can say HNSW is another improvement. If you had just said I'll take top K and I'll do ANN, you can say HNSW for high scalability. You have to be also ready with the future scope, isn't it? Now my question is,
why don't we push the self-evaluation to the LLM service? Why do you think I didn't do this?
Because it will be in loop if we
Because it will be
it will be in loop if we do the self-evaluation for the LLM service. Someone has,
self-evaluation.
I mean,
Self-evaluation.
some other should service should be there in order to evaluate instead of doing themselves.
Okay. So if you put self-evaluation in the LLM service, then the first thing is rule-based engines are simple. Rule-based engines are simple. And if you match the rule, you say yes, otherwise you say no. LLM service does reasoning. I don't need reasoning in all those things. I need simplicity. I have hard-coded rule. If $5,000 is what I'm seeing, more than that, I'll not pass it. Why do you need reasoning in that? You don't need reasoning. So for some hard-coded rules, I'm looking for simplicity. Simplicity is going to give me low latency. Simplicity is going to give me no hallucination or no nonsense. Hallucinations can happen if you start thinking, but if you become a military personnel, where you don't think what you are doing, you just take order and you do. Then what is there to hallucinate when you don't think? Okay, so no hallucination chance. Then low latency is already we have seen. Separation of responsibility. Separation of responsibility, modularity, everything comes with this. Scalability. Scalability comes into picture because you are now having a separate thing altogether. Easier maintainability. Maintainability is also there, which will improve because they both are now separated. Can we add any more point to it? We cannot provide hard guarantees. Hard guarantees can be provided by rule-based engines. So many a times, like in medicinal use case, hard guarantees, that means rule-based engine is used in combination with LLM service. You don't just use LLM service, it's not a magic. Okay, don't think everywhere. Provide hard guarantees where you need it to be. So it should be a combination of that. And I think policies can be uh, a deterministic. Deterministic means you exactly know why it passes or why it fails. There is no nonsense to it. And this relates to the hard guarantee. It relates to no hallucination as well. It leads to no hallucinations, right? Cost is less, low cost. Because if you are not thinking, you are not using enough resources, you are maintaining low cost, not just low latency, right? So a lot of points are there, isn't it? Isn't it? Auditability is easier. Auditability, I could say. Many a times you just need a simple rule of why audit. Okay, the spelling is not correct. You can just check it. Auditability. You just need simple rules to say why something failed or why something passed. Right? So since we are already using a reasoning layer, now I don't want another reasoning layer. Two reasoning layer can also club together and produce some kind of nonsense. So once we are using a reasoning layer, the other has to be a rule-based engine. Policy implementation is easier in that case, right? So if I have to ask you in terms of agent, how many agents would you use and for what purpose are you going to use it? So let me just make somewhere. Okay, so let me make here. What all agents are you going to use and how would you be using it? Let me remove this. When the request comes to the agent service, the first agent can be a transaction handler because anyway, you are going to handle the transactions. Transaction handler is required. Okay. Second thing can be, you can say self-evaluation agent. Third thing can be a rule enforcement agent. Rule enforcement agent. Then you can have a reporting agent. Let me tell you, the transaction handler will take care of how the transaction orchestrates. That means what is the state of the transaction in the Redis, and what should I update in the Dynamo, when should I update it, when should I set or reset the flag, what others are talking about this transaction, is it happening, not happening, and whom should I ask to start the process. All these, how the transaction goes step by step, all these things are done by the transaction handler. Self-evaluation agent. Once the result is given by the LLM service, what are the points on which you should check and who will check that? Self-evaluation agent will extract the required information from Redis and match it. Okay, so this is a separate agent. Now you have the rule enforcement agent. Okay, now there can be some set of rules. The self-evaluation agent can be given a separate responsibility. Like whatever I said for the self-evaluation agent, you can pass on to the real rule enforcement from the Redis, whereas the self-evaluation can check with some other set of rules of whether I need to redo the process and to which step should I go back to. That can be the job of self-evaluation. Rule enforcement will be some hard code rule-based engine. What rules are present and is it passing all those rules or not passing? Reporting engine will be finalizing your report and framing your answer and how it should be sent and how it should be represented, how it will be stored in Dynamo, how the packet will be prepared for the answer. So it will also be reporting to the vector DB. Vector DB needs embeddings. So maybe you can have an embedding service for that, embedding an encoder for it. And then you need a simple writer for the Dynamo. So you can have all these things, separation of, you can say, responsibility, right? So with this, I think we have come to a close of our design, right? The fraud detection. And I think you enjoyed it, isn't it? So whoever stayed must have enjoyed it. Okay. Right. So I think I should stop the recording now. Yeah. So you have any question?
Yeah, Surya, one question.
Yeah.
How do we ensure that this ML model, I mean, it is part of like Flink architecture only, or it is hosted somewhere else? How do we
It
ensure
can
that it is
be it can
running?
be hosted just at the output of the Flink, so that the output of the Flink is coming and the one node is present with the classifier, and that one node is just deciding based on whatever is the output of the Flink, what should we do. So just a single node can be maintained at the end. Okay, I have shown you
But it is,
already. Hmm.
yeah, but it is not. I mean, one node. I mean, but it is running parallelly, right?
Parallelly means you can make
Parallel.
it you can make it parallel. You can have many nodes in parallel, and you can throw your output of the Flink to many parallel nodes because ML model is not changing here.
Hmm.
ML model is changing on the backend from the Dynamo getting processed, right? So when I say one ML model, you can have one or more nodes there in parallel taking all the requests, isn't it?
Okay,
Yeah.
got it. And I mean, the storage for this. I mean, the model. Um, how it will be stored and what memory it will take.
Which one?
So you say that model keeps getting updated, right? So, but where it is, what memory it is taking?
It is just
The
a classifier. Like
Okay,
you think about a classifier. Where will you load? What will you do? A simple classifier service.
okay.
It will use an ML model and it is just passing through the classifier. Input to a classifier, output of the classifier, right?
Size. I mean, its size can get increased or decreased. That thing I'm asking. That can
Okay.
it
Its
become?
size will definitely generally not be changing because it's just tuning the parameters rather
Okay,
than doing something else. You think about a deep neural network. In that you have a lot of layers, but the layers and nodes are not changing. Rather, the weight of the edges are changing,
okay,
how they're connected, right? So it is becoming more and more refined. Weight will continuously change based on the user behavior as well.
okay,
So that is how the classifier works, isn't it? So it's not going to change anything, no change in MB, GB, whatever.
okay.
It's just going to be the same model. Okay. So with this, yeah,
So,
Rakesh.
yeah, we were discussing this context reloading for the optimization, right? From
Mm,
Kafka to Flink. So here, when we are trying to send the similar partition data to the respective worker to the Flink, so that
mhm.
aggregation and sorting of the similar things we will be handling from the code, or will it Flink will take care of that? So we are trying
Uh,
to reduce the shuffling in the Flink,
mm,
right? So
mm,
in the sense, suppose worker node, suppose in the employee ID, 1 to 10 employee ID is processed by worker node 1, and 10 to 20, I'm just saying 10 to 20 employee IDs are processed by worker node 2. So those we already have the respective partitions topics in the Kafka, but when
mm.
we are processing that from the Kafka and loading to the Flink, that segregation, aggregating and sorting, are we doing, should we handle from the code, or do you mean that Flink will
So,
handle?
so when I said context reloading will not happen, I tried to say that the same partition users will be sent to, let's say, same worker nodes.
Okay,
So the worker node will not have to again ask for the state of the user because it has once loaded it. If it was going to some other worker node, then it will again have to reload it. What you are saying is shuffling, which is separate from that context thing a little bit. But anyway, if same set of users are coming with similar work structure, then they will not be shuffling across the node suddenly. Because shuffling means aggregating similar things at the same place. But if all
correct.
the similar things are already at a similar place, then you will need less shuffling, isn't it?
No, no,
So shuffling,
who will take, who will handle that?
I
Like,
mean, that is the Flink's work, right? That
Flink.
Yeah, Flink will in the map reduce. If you say who will do that, then
Okay, okay,
it is the reducer's job to scan every map node and think about whether to pull that item or to not pull it.
okay,
And who will tell the mappers or the reducers where the mappers are present? There is a master node for that, isn't it? Who will tell all the reducers where the mappers are?
okay. Fine.
Yeah.
Thank you. Yeah.
So anyway, like I hope you guys enjoyed this. So these are like you see this. My intention of showing this was how this AI and system design is coming together, isn't it? In the past, most of you guys have already done a design. I think 90% of people present here are already into my design course, right? So we might have done one part of it, and so this part is what we are trying to focus on the AI for SD. This part, that how this part works, how you think about this part, how you can explain at a lot of depth about this part. What we said is very high level stuff, and then once you think about it, how it works in a pipeline, how to design all those pipelines, and all those complexities of an AI engineer, then you can be more of an hybrid engineer, like a software engineer come AI engineer, right? Software plus AI engineer, something like that. So it is not a full-fledged AI engineer because you need to study mathematics, you need to study machine learning and a lot of other things apart from SD. So those are two separate things. But I think the current requirement is a hybrid one, isn't it? And these requirements are currently ongoing for senior engineers. Uh, yeah, if you answer something apart from this, your score definitely is going to not be very good. And you can also look into your own company that how much they are focusing on AI KPIs, and you can make out that if somebody answers in such way in the interview, can get unfairly more marks than somebody else, isn't it? Even though there will be very little to no knowledge gap between you guys, right? So, these small things now matters a lot. 2 years in line, things are again going to change. Things will again be like more and more in depth, how much in depth you can go. But right now in 2026, at least, this is going to be the mode of interview. To only cater to this need, from last year only, I am preparing this course for AI for SD to cater to this need for 2026. For 27, again, I'll be preparing by the end of this year. And then again, next year, the same AI for SD will have a separate course structure. So, every time you do the same course, it is like going to be completely separate thing. So you can just see like what you need to change in the interview. And definitely the design part that you have covered is a very essential if you have already covered it, because that is not going to go anywhere. It's not like the design is becoming irrelevant, but it is becoming more and more relevant now. You can't make mistake in the distributed design here and do good AI design, because again, that is a given thing that you should do, isn't it? That's a given thing. That should always be correct. Based on that, you have to add an additional, uh, service and get the entire thing done, right? So anyway, this is just a master class and an announcement about the new course starting on 11th of April for both AI for SD and the design. If you are already a past member, you will get discount on the design definitely if you are already into the design, right? So anyway, you can consider that too if you need. And I hope you enjoyed this, right? So you can be in the alumni group so that you can keep getting the updates about at least the master classes in future. Okay. So yeah, and this video will be uploaded on YouTube in some time, in few days. So you can again rewatch that. I can share it in the group, right? Because once I do some masterclass, probably I'll not be doing it again, isn't it? So that will be too much of an ask.
If you are someone who is preparing for top product based company interview, then we have brought for you live interview training program based on data structures and algorithms, system design and AI for SDE. This will make sure that you cover all the requirements for data structures and algorithms, be it online assessment or the face to face rounds. We will be doing live practice on coding as well as discuss the assignments. We also have a self paced number theory course which you can take for difficult online assessment and face to face interview preparation, like Google Media.net and Code Nation. And for system design, we will be discussing the distributed design along with components, HLD, LLD. LLD is a self-paced course here, and we will be discussing everything keeping the AI aspect of design in mind. That is how AI agents will come into our design and how to develop AI features in the pre-existing design. This will definitely give you an edge in the current AI era. And then we have AI for SDE 6 months live training program where you will be getting to build a LLM right from scratch. Along with that, we will understand the entire pipeline of Agentic AI. And this is not just a theoretical course. We will definitely be doing hands-on for each of the concept that we learn on Python using Jupyter Notebook or Google Colab. If you do not know Python, then definitely we will be learning it on the go. To know more about this training program, you can WhatsApp us on this given number or visit our website techdose.co.in.